Всем добрый день. Меня зовут Фролков Иван.
Good morning. My name is Ivan Frolov. Welcome at Postgres conference. I would like to invite Alexey Fadeev, our speaker, who will tell you about foreign data wrappers and foreign data wrapper versus PL Python. Alexey, over to you. Hello. I work with Postgres. I develop on .NET. So I see technologies develop in real projects. Back to my topic, everybody knows, or many people know, about foreign data wrappers, FDW. It's a technology that provides access to external sources of data in the form of a Postgres table. One of the goals was to get access to API. I started looking for it and to make sure there is a FDW available, because there are a lot of them in the community, but all I could find did not work with API. It worked with the file. You need to download the file offline, and you will not get all the data but a limited area, which is not good. You can certainly develop your own foreign data wrapper as any permission. In Postgres, it is done on C++, but the task did not worth developing it on our own. I've heard that there is multi-core technology which allows to write FDW on Python, which is simpler and faster. So please follow the link to read the documentation with examples. There is a report on one of the conferences, GTON. You can read about this technology. I've never developed on Python, but I found an example in multi-core, and I redid it for my purposes. So the full code fits into one screen, which, of course, is very compact and elegant. So how does multi-core work? From the technology point of view, this is one FDW, but different servers interact with a specific code on wrapper. You further do create server and work with a script. In this case, I had OSM of DY is my script, and it works with 3 different functions. After you create servers, you will create external tables and indicate the appropriate server. In this case, OpenStreetMap has 2 types of objects, a line and a dot. So all knowledge is lines. Dots can be inside the lines or outside the lines, and for them I created different tables. This is an example of a query for the identifier. Just to make it more interesting, let's have a look at real data. For example, this is the city of St. Petersburg, Rubinstein Street. Let's pick a dot, a point. Let's say it's a fast food restaurant. Let's pick a location, identify it, and then perform a query. This is what I do. This is my external table. I apply to my external table.
And
download data, get the coordinates of this location and the tags, including all information which can be visualized, and it is contained in tags. It was a location at dot. Let's take a line. Let's pick a building. You can see the tags, and we'll get hold it in Postgres. We should write where and change the identifier. with the appropriate
И
one.
опять же, вот у нас подгрузились
And
данные, да,
again,
в виде
we have
таблички
data
Postgres теги
downloaded in the form
и
of Postgres
точки,
table
идентификаторы
tags
точек, которые
and
входят в эту линию.
location identifiers,
Все
which are
хорошо,
included
все
in this
работает.
line. Everything is good, everything works.
И следующий пример, это вот эти
The
же самые
next
теги, я их
example
сделал в
is
виде
the
колонки
same
типа
tags
HStore. Мы
in
можем
the form of
развернуть
HStore
HStore в виде таблицы. Сейчас я
in
тут
the form of a table.
запрос подготовил, чтобы
So
долго
I've
не набирать.
prepared a query so that I don't type in front of you.
Да, ну и давайте, собственно, вот
So
того же самого
let's
объекта. Да,
do the
возьмем наш
same. Let's do
идентификатор
it for the same object. Take our identifier
и получим вот теги в виде таблицы.
and
Вот,
get
ну
hold of
и
tags in the form
да,
of a
все
table.
то же самое через нашу внешнюю
The
таблицу,
same
вот эту
through our
OSM test way,
external
которая
table
работает
of
с
OSM test
API.
way, which interacts
Пока
with
все выглядит замечательно.
external
Идем
API.
дальше.
Things
Посмотрим,
look good so
как
far.
устроен
Let's
мультикорн
see
внутри,
how
как он
multicorn
работает
is
с условиями
organized
where, то есть
and
входными
how does it
параметрами.
operate
Вот
with
в основной
where, with
функции
input
execute есть такой
parameters. In execute
параметр quotes.
function, we
Это,
have
собственно, и
quotes
есть наши
parameter,
условия where.
and
И
these are our OVR
этот сам quotes
conditions.
это массив,
This
он
quotes
перебирается,
is an
и
array.
дальше конкретный quote, то есть
It is
условий where может
viewed,
быть несколько, но у нас в
and
данном
there
случае
might be
одно в
several
моем
conditions
примере.
of where,
У него
but
есть
in our
field,
case
это
we have
будет
one. It has a field.
ID,
Wall has
название
a
поля.
field. ID is the name of the
Оператор
field.
равно, и value это значение
Operator equals, and
конкретно
here is
нашего
the value,
идентификатора. То есть
the value of
я
our
сделал в своей
identifier.
функции
In my
вывод
function,
логового сообщения, вот мы можем посмотреть,
I have this log
если мы откроем
report
сообщение, вот
here.
идентификатор
If we check
выводится,
the
а
report,
дальше также
we can
выводится
see
лог,
the
ну,
ID
собственно, уже
and
endpoint API, который
the
к этому
endpoint
wrapper
API
обращается.
to
Но
which my
теперь
wrapper
усложним запрос,
calls
попробуем
upon.
взять несколько точек.
Let's complicate the
Напишем
query.
select
Let's
с
take
оператором in.
several points. Let's
Смотрим,
say
что же приходит
select an in
в
operator and
сообщение,
see what we get
ну,
in
то
the
есть приходит
report,
в наш
in the
мультикорн
message.
в виде
What do
параметров.
we get in our
Видим,
multicorn
что
as a
вот такую
parameter?
конструкцию, то
We
есть это
see that this
преобразуется
is
в
the
массив, и
design.
конкретное
It is
поле value
transformed
это
into
действительно
an array.
pythonский массив,
In the
который
value
уже не
field,
нужно
we
парсить,
have
это
the
не текст,
Python
а массив, видим,
array.
class list,
This is
и с
not
ним
a
работаем.
text,
То
this is
есть
array.
мы можем
It is called class
в
list,
мультикорне,
and we
в
work
нашем
with
коде,
it.
ну,
In
написать разные
multicorn, in
случаи
our
обработчиков.
code,
Если нам пришло скалярное
we can
значение
select different
или
cases
пришел
if it's a
массив.
scale value
Тоже
or
пока все замечательно.
depending of whether it's a scale value or an array
И
value.
да, это был запрос с оператором in. И
That
если
was
мы
a
можем
request
также
to in
написать собственный массив,
operator.
будет ровно то
We
же
can
самое.
write our
То
own
есть, скорее всего,
array
оптимизатор
and we'll get the
Postgres
same. The
приводит к одному и
Postgres
тому же виду.
optimizer will bring it to
То
the
есть вот с
same
массивом
view.
вот так тоже такой запрос работает.
So with
Теперь
array,
попробуем
this
сделать
query
join с
works as
таблицей. То есть,
this.
допустим,
Let's
у
do
нас
join with the
существуют
table.
таблицы с нашими идентификаторами,
Imagine we have
например,
tables
точек,
with our
и мы хотим сделать
identifiers
join
of points. We
с
want to
нашей
do
внешней
join
таблицы. То
with
есть
our
мы
external
имитируем таблицу с
table.
помощью вот
We
такого селектора
simulate
с
the
юнионом,
table with
вот
select
с двумя значениями.
and
Делаем
union
join.
select
Смотрим,
and do
что же
join
приходит в
and
мультикорн.
see what
Приходит
comes to
пустые скобки, не
multicorn.
приходит ничего.
Empty
Честно говоря, это меня
squares,
очень сильно
nothing
озадачило. Я
comes.
стал
This
искать,
puzzled me, and
можно
I
ли вообще,
started
поддерживает ли вообще
looking
мультикорн
for the answer.
join.
Is it possible to support multicorn
И
with join?
нашел примеры, но примеры были следующие.
I
То есть,
found the
если
examples
ваш
like
foreign data
this.
wrapper на
If your
мультикорн
foreign data wrapper on
работает, но
multicorn
с каким-то ограниченным
works
количеством
well,
данных.
but
То есть,
with some
например, читает
restriction, with some limited amount
какие-то
of
объекты из
data, for
файла,
instance, it can
предположим, в
read
этом файле
objects
у вас
from
там 10
file,
тысяч
and in
объектов.
that
Если
file
вы
we have
пишете select без звездочки,
10,000
без условия,
objects.
вам возвращается все 10 тысяч. Если вы
You
делаете
may
вот
get
такой,
all those
например,
10,000
join,
back. If you
вам
do this join,
этот wrапper все равно возвращает все 10
this
тысяч
wrapper will
объектов, а потом
return all
Postgres
those
уже делает
10,000
join и
objects to
откидывает
you, and
ненужные.
Postgres does join
Решение, мягко
and
говоря, не
falls
очень элегантное,
and
но, по
throws
крайней мере,
away
оно
the
работает. Но
unnecessary
в
one.
нашем
This
случае
is not an elegant solution, but
с
it is
REST
a
API
viable
это решение
solution.
вообще никак не
In
работает,
REST
потому что
API,
мы не можем
it is
получить
not
все данные
applicable.
OpenStreetMap,
We
их
cannot
очень
get
много,
all the
и
data
даже
of
такой функции опять
OpenStreetMap.
нет.
There are too
Поэтому
many of them.
мы вообще ничего не можем сделать.
That's why we
Не
can
можем
do
сделать
nothing
join.
here. We cannot do the join.
Но поскольку, как было на предыдущих
Because,
слайдах,
as I showed in
мультикорн
the
работает
previous
с
slides,
массивом, я
multicorn
попробовал
worked with
нашу таблицу
the
сегрегировать
array.
массив
I
через
tried
array
to
агрегат
aggregate the
и,
table
собственно,
into
выполнить
an
запрос, который работал
array
для массива,
and
который
performed
был
a
явно
query
задан в
which
тексте
worked for the
запроса.
array,
Но, тем не
which was
менее,
in the
для
text of the
агрегированного
query,
массива тоже
but
ничего
for
не
the
работает.
aggregated
Тоже
array,
приходят
things
пустые
didn't
скобки.
work, so we
Ну,
get those
не знаю,
square
может быть,
parentheses.
оптимизатор Postgres заменил эту
Maybe
агрегацию
Postgres
массива на join, на самом
optimizer
деле,
changed
и
this
сделал.
aggregation to join
Не
and
знаю,
didn't
вот,
do
или
it.
можно
It's
по-другому,
hard
с
to
join
say.
lateral
Or
написать
maybe we
то же самое
can
с RGG, тоже не
write
работает multicore,
join later, but
ничего не
it doesn't
приходит.
work. Nothing comes to
Тогда я
multicorn.
взял
Then
уже таблицу,
I
где уже
took a
содержится
table
массив, то есть я ничего не
with an
агрегирую, уже ввел
array,
готовый
and
массив.
I didn't
Точно
aggregate
так же
anything. I took
пытаюсь
the available
с помощью
array
оператора array
and tried to use any operator
условия where для нашей внешней таблицы поставить, и опять
where
multicorn
ID
ничего не
condition.
приходит.
Again, nothing
Почему
comes to
это работает
multicorn.
для
Why does
массива,
it
который
work for
явно
the
занят в
array
тексте запроса, а вот
which
для
is given
такого
in the
случая не
text of the
работает?
query, and it doesn't work
Но,
for in this
наверное,
case?
если посмотреть планы запросов, может быть,
If we
нам
have a
это
look
что-то
at the
скажет. Но
query
пускай этим
plans,
занимаются
they might
разработчики
help us,
мультикорна,
but
если они
let the
хотят
multicorn
свой инструмент
developers deal with it
улучшать.
if they
Пока
want
мы
to
имеем то,
improve
что
their
имеем.
tool.
Ну,
We have what
join
we have so
практически
far.
невозможно сделать в
Join
таком виде.
cannot be
Точнее,
performed
я
in any
нашел
fashion.
один кейс, когда join сделать
However, I
можно.
found one
Если
case
в
when
таблице,
join
с
was
которой вы joiните,
possible.
ровно одна строка,
When you
тогда
join
у
in the
нас
table,
наш multicorn
there is
format
only one line.
приходит
It is
в
possible.
условии вот в таком виде.
So the
ID равно,
condition
то есть
comes in this
скалярное
form, ID
значение.
equals, and then the
Да,
scale
можно,
value.
конечно, обрадоваться, что хоть что-то у нас работает,
You may be
но с
happy that
другой
this is
стороны,
working, but
не
on the
очень мне
other
нравится
hand,
решение, когда у
I don't
нас
like this
вот с
solution
одной строкой
where
работает, а с
it
количеством
works
больше
with one
одного нет. То
line,
есть
but it doesn't work with more
работоспособность
than
зависит
one
от
line or
количества
one
строк.
string.
По
So
мне, это
it is
чревато,
string number
как
dependable.
говорится, выстрелить себя в ногу, особенно если у
This is
вас
like
вновь
shooting
разработчик
yourself
сначала
in the
так
leg,
написал, потом
especially
другой,
if
который этих
you
нюансов не
have
знает,
a new developer who comes
начинает
and
менять
doesn't
количество
know all
строк,
the
и у него
subtleties
все
and
это
starts
перестает
changing the
работать.
number of strings
Теперь
and things stop
рассмотрим
working.
альтернативный вариант, который был
Let's
заявлен
have a
в
look at
докладе.
an
Это не
alternative,
multicorn FDW, а PL
not
Python. Расширение, которое
multicorn
позволяет писать хранимки на Python.
FDW, but
То есть я взял
Python,
прямо тот же самый код,
PL
который был
Python.
у
I
меня
took the
в
same
моем
code
multicorn
that I
wrapper,
had in
скопировал,
multicorn wrapper,
и это
copied
заработает.
it, and it worked.
То есть вот два аналогичных запроса. Один делается
These are
через
two
multicorn,
similar
другой
queries, one via multicorn
вот
and
эту
the other
самую
performed
хранимку на
via
Python.
PL Python.
Покажу, что все работает.
I'll show you that it works.
Ну, давайте тот же самый объект возьмем.
The same object. Let's take the same one.
То есть теперь уже да, не мультикорн, а вызвали функцию и
Not multicorn, but we called a function and the same data arrived. Things work well.
И теперь, собственно, то, что у меня никак не получалось
And
сделать.
now this is what I couldn't do with multicorn FDW. If in the table we have several identifier values, I wanted to join them and get hold of data from OpenStreetMap. This query works here. In this very case, we call the function getNode. Per identifier will be called upon for each string. The same query for multicorn FDW doesn't work. Nothing comes to the condition, to the ID. If we don't want to call the function several times, we can do it differently. Aggregate a table into an array and write a function which assumes array as an argument. This is a workable solution. So the practical task for which I did all this, to get data of the line from OpenStreetMap and identifiers of the line, and then get hold of its data, coordinates, and tags. Let's take a live example.
Собственно, возьмем, допустим, тот же самый объект.
Let's take the same object. This is the query text.
Ставим наш идентификатор, который мы с OpenStreetMap.
This is the identifier taken from the OpenStreetMap. The query is performed for quite a long time, and I will explain why it is so long. So here we get all the data of the point, and all points have coordinates, and some even have tags. Let's check the messages. Via API, we receive data of the line and data of each point. For each point, we have to do a separate API call, which is not a very beautiful solution, but for some cases, it might be good when foreign data wrapper operates with files.
пришлось бы, ну, для получения
we
данных из
have
каждого файла обращаться к нему, и поэтому
to
такой
call
вариант,
upon it to
ну,
get data
был бы
from each
вполне
file.
подходящим.
So it would be
Но
a good
или
option.
другой вариант все-таки,
Or there is another
если нам
option.
нужно вызвать, если мы не
If
хотим
we
вызывать
need,
каждый раз
if
функцию,
we
мы
don't want
опять
to
же
call the
передаем
function
массив
every
и
time,
вызываем
we
функцию на Python,
give
которая
the
принимает
array
массив.
and
И этот вариант
use
тоже
the
рабочий.
function
Но,
that
правда,
accepts the
в
array.
OpenStreetMap API
In
нет такого
OpenStreetMap
endpoint, который
API,
принимал бы
there is
массив.
no endpoint that would
Вот поэтому,
accept the array.
да, я его реализовал, но внутри он
I
также
have
в цикле.
implemented it, but inside, in the cycle,
Да, давайте попадем. Так. Теперь все-таки у Multicorn FDW есть небольшое преимущество, в отличие от PL Python. Он
FDW
поддерживает
has
тип
an
HStore.
advantage.
То есть в данном случае
It
информация
supports
от тегов,
HStore type.
колонку для
Information
тегов
from
я
tags,
сделал
tag
в виде
column
типа HStore.
is in the form of
И в
HStore,
Multicorn мы
and in
просто
Multicorn,
можем использовать ассоциативный
we
контейнер
can
Python, который
use
автоматически будет преобразован в
associated
HStore.
container of
Multicorn
Python
это
to
умеет
be
делать сам.
converted
PL Python
like
этого
this.
делать не умеет,
Multicorn knows
поэтому
how to do this.
нам
PL
приходится
Python
формировать
cannot
HStore
do
в
it,
виде
so we
строки,
have to
что
form
немножко усложняет
HStore
текст.
in the form of a string,
Но,
which
кстати сказать,
complicates the text.
тип JSONB, который
But
имеет основу на том же самом
JSONB,
языке, что HStore,
based
поддерживается
on the
и
same
там. Поэтому
engine,
можно
is
использовать
supported in both
JSONB,
cases. You can use
который более
JSONB,
новый, более совершенный. Но
which
все-таки
is
иногда,
more
мне кажется,
recent, more
удобнее бывает использовать
perfect.
HStore.
But
Но
sometimes
если
it's better
данные,
to use
например,
HStore,
совершенно
especially
точно знаете,
if
что одноуровневый, только строк,
data
то
are
тогда
single
HStore, мне
tier,
кажется, лучше
then
отражает
HStore
структуру. Вы точно понимаете,
reflects the
что это такое.
structure better.
Вот в этом
You
случае
better
Multicorn
understand what
немножко
you are
лучше.
dealing with. So
Теперь
Multicorn is
еще
better
одна
in this
функция
case.
API OpenStreetMap.
One more
Все-таки есть
function
функция,
of
которая
API
позволяет
OpenStreetMap. There is a function
за один вызов, за одно обращение
that
к endpoint получить
helps you
данные по
get
сразу по группе
hold
объектов,
of data
но
on a group
вам
of
нужно
objects
передавать
with
область
one
из
call,
координат.
but you need to
Вот.
provide
Я тоже сделал
areas
внешнюю
from
таблицу
coordinates.
для
I
начала
created an
на Multicorn
external table
скрипте.
on
И, соответственно,
Multicorn
вот
in my
параметр
script.
bbox — это
These are the
массив, в котором мы
parameters
передаем
bbox.
4
This is the
координаты. В
array
принципе, с тем
with
же
4
успехом можно было
coordinates.
сделать 4
You could
разных
have done
колонки
it with 4
для
different
этих 4
columns
координат, которые
for the same
ограничивают
4
нашу область
coordinates,
на карте.
which limit our
И
area on the
опять же,
map.
я сделал два варианта. То есть один
So I've created two
через
options,
foreign
one
data wrapper Multicorn,
through
и
foreign
другой
data
через
wrapper
функцию.
Multicorn,
Ну, в
and
данном
the other
случае
through a
код
function.
SQL
In our
скрипт через
case,
функцию даже
it is
немножко более
SQL
компактно
script.
выглядит.
SQL
И
script
давайте
looks
тоже
more
на реальных
compact
данных
and
это
concise.
посмотрим.
Let's perform this on real data.
Скрипт. И возьмем, опять же, с точки на карте, вот прям
We'll take a
возьмем
point on the map.
вот эти координаты настоящие.
Let's take the actual coordinates.
Здесь только у нас широта с долготой менее местами, то есть у меня
The
меняется
latitude
карта в
and
endpoint. И здесь нам взять,
longitude are
соответственно, немножко больше области.
have changed places, but it doesn't really matter.
9. Давайте попробуем. Вот, запрос выполнился довольно быстро.
So we
Нам
performed
пришло
a
ровно
query,
1000 строк. То есть, видите, это
and we
все
received
точки, которые попали в
1,000
эту область.
strings. So
Соответственно,
all
помимо
points that got
обмена
into
все
that
данные,
area, we received data on all those points. We receive all the
и давайте
coordinates.
сравним альтернативный вариант. То же
Let's
самое на
compare an
PL Python.
alternative option. The same on PL Python.
Как называется? Get notice просто называется. И те же самые. Смотрим. Да, та же 1000 строк пришла.
So we get the same 1,000 strings, the same data, but if we compare this, you may see a slight difference. In Multicorn, we have a column, what we send to where. When we create where, we create a column, and it appears in the output. And because there might be a lot of strings in the output, there might be some excessive data joining those strings. But we need to fill this out, otherwise you will not receive those strings. This is how Multicorn operates. Of course, in select we may not indicate those strings and indicate only what we need. But in this case, In Python, we don't need to receive these data. And I decided to compare the performance. I took a slightly bigger area on the map with over 30,000 lines. I called upon them several times, and these are the milliseconds for PL-Python and Multicorn. We see that PL-Python is slightly faster, and we see a distribution. I then understood that I didn't measure accurately because these measurements include receipt of data, because it takes the server to form the data, about 8 megabytes that we attract. So for the test, I took the file, saved it, and posted it on this local server where the Postgres is deployed. Then download was immediate, and the data became more representative. I made several measurements, and we see that it has become 4 times faster because we don't take a big file from the internet, and PL-Python is better by 30%.
And we can assess performance this way. We receive this code, we receive the data as XML file, and after that, the code returns the data in the form of Postgres strings, and performance is about 30,000 strings per second. And if this is not a high load system, I think that this is quite effective. Another advantage of Multicorn foreign data wrapper is that from this outer table you can not only read data, but also introduce changes, execute insert and update operations if you need it. Because in this case, this is read-only source. But there can be various cases. That's why when you need to have insert and update, probably it will be more convenient to use Multicorn foreign data wrapper. Of course, SQL language is also supported by Postgres. The operators insert, update, and join data wrappers as well as selector will not function with it. But changing the data string by string, enter by entry, in many cases this will be available and like select operations. So, if we compare foreign data wrappers that allow us to use the flexibility of SQL functionality, then of course it's more convenient to use SQL. Because when we use storage, we can get some limitations. But this is not about Multicorn FDW, because of course we can write SQL, but as I said, these joins never work. And on PL-Python, we have more opportunities. We use more difficult, more complicated constructors, such as join lateral. The syntaxes gets more complicated, but we get a working solution that we didn't manage to get on Multicorn. And the process of writing code on PL-Python is simpler, because on Multicorn you need to deploy script, create a server and an outer table, and in case of upgrading, it's necessary to drop the table, the server, recreate the server and the outer table. But thanks to this function, you will have only one operator, outer function, and that's it. Speaking about performance, PL-Python was a bit faster, not 3 times faster, but still it is 30% faster. And the last 2 points, these are the advantages of foreign data wrapper. They support insert and update. Of course, you can use function for it, but you will have to write different functions for receiving the data and updating them. But thanks to Multicorn, you can do it with one outer table, and Multicorn supports each store directly. Python doesn't do it. JSON-B is supported by both. So, in conclusion, I would like to tell you about the way I decided to choose this topic. Well, I was looking for FDI, and I realized that it was not reasonable to write it on C, but I've heard that you can do it on Python. So I found MultiPython, It was much simpler compared with C, but it turned out that using PL Python, it can be even simpler. So my message is that if you've heard about multi-core, that it's possible to develop wrapper on Python, before starting writing it, probably at first you should compare it with PL Python and decide what's more suitable for you. And this was an R&D. I haven't used neither multi-core FGW nor PL Python in my real projects, but I used another alternative language. This is PLV8, and I have a major framework that allows me to fulfill complete cycle of development with debugging and automatic deploying and many other things. Now I'm gathering information and I will speak about this topic on future conferences. I think it's really interesting and I hope that the organizers think so too. And you will be able to see this presentation in the future. That's it for me. Thank you. I would like to thank Alexei for his interesting presentation. And I would like to remind our participants that if you want to ask some questions of the speaker, you can ask your questions on the chat. And I would like to make the following question. Have you tried to make wider benchmarks and use them on long and short queries, and what results have you received? Of course, the results can be different on different number of entries. I haven't tried large benchmarks. The reason is that the use of foreign data wrapper is limited by other factors. If FDW was faster than PL Python, probably in that case, I would think what is more needed for me, this performance or the opportunity to make a join. But in this case, PL Python was better in both cases, so I did not have this need. It hasn't reached production yet, and if it does reach production before selecting something, I guess that I will fulfill benchmarking testing in a more meticulous manner. Okay, have you tried using just-in-time compilator for PL Python? No, I haven't. Thank you for the idea. Will we have other questions on the chat?
In
that case, I would like to invite all our participants to special chat. There you can talk to speakers, discuss everything. It will not be on air. These are talks behind the scenes in online, and I can add that on these slides. You can see my contact data, you can write me, or you can download the script for FDW and you can try launching it. So, I guess that we can conclude our Q&A session. I would like to thank the speaker for the interesting presentation. And now I would like to remind you that every participant can organize their Meet app. There is a link, or for a topic for discussion, you can fill in the form, and we will be able to discuss everything. And now we will have a break. We will restart at 10:40.
Мы вернулись в эфир, продолжаем нашу конференцию, и я хотел бы пригласить в эфир следующего спикера.
So we're back on air, we continue our conference, and I would like to invite our next speaker, Nikolai Ryzhkov. He will speak about the management of SQL data. The floor is yours. Thank you. Just a minute, please. My name is Nikolai Ryzhkov. Probably my presentation is a bit unusual. I am Samurai team manager. We develop a medical platform and application on it. And we even devised a profession of holistic engineer. So it's not just a full stack, because full stack is back and front, but we make full stack plus DevOps. So we do everything up to business analytics. It's an interesting and universal approach. And our three main technologies or areas of work are Postgres, Clojure, and Fire, that is an open medical standard. Each of us has their own community, and we develop these communities. And here I decided to develop an experimental talk. I will speak about the way we work with Clojure and Postgres. And mostly, I will speak about Clojure. My presentation will be interactive in Emacs. You can see the code of my presentation on GitHub. Here it is. There is a library, and there is slides folder. So if you want to try it, you will be able to execute everything that I show today. So let's start. Clojure is very small language. So we may learn it within 5 minutes. I guess that many of you do not know it, but it's quite simple. So for your reference, I'd like to tell you that Clojure is a functional list that can be hosted on JVM or JavaScript runtimes. This language was devised by one person, Rich Hickey, and in my opinion, this is a very serious thinker. Of our age, we have Michael Stonebreaker, and Rich Hickey is quite similar to him. So please find his presentation. You can listen to such lectures as Simple Made Easy or Programming in a Hammock. These are very serious talks. Clojure, how can we understand it? Well, you can think of any dynamic language that you know. JavaScript, Perl, Python, Ruby, and after that, we start computing. We start removing the extras, and after that, we will get this Clojure. This is a small conceptual language, but it's quite powerful. I think that this is a king or a queen of dynamic languages. First of all, we get rid of syntaxes, because this is Lisp. That's why we do not need it. After that, we remove mutability. Most data structures in Clojure are mutable, persistent. It means that we can write on Clojure in a functional style, and actually not all Lisps are functional, because in Clojure the main data structures are immutable. It means that most part of your code will be pure functions. After that, we remove classes, objects, and other issues. In Clojure, we used only generic data structures, maps and vectors, and functions. That's it. And we also remove the difference between design time, runtime, compile time. We interactively develop this program. We will see it today. This is repo-driven development. So we actually interact with runtimes in an interactive manner. This is the way we develop this program. And remove all other rituals that doesn't function. We only have functions and data structures. So it's like a matrix. Before learning to read Clojure, you need to understand that this is a Lisp. The Lisp is built on as expressions. So you can see that in route brackets, this is a formula and an argument. So you can put the symbol or you do not have to put it. And this is the way we will write down operators, functions, and macros. This is a form. For example, let's imagine that we call this function. How will it be written? We just put this bracket in the beginning and remove commas. So we are calling this function. I executed it, and now we can see the result. And I do it in a similar way with the operators. We put the operator in the beginning, place everything in round brackets, so we can remove the extras. And this is the way we call the operator. So if you think about it, actually it looks like AST. If we parsed it, if we used C like language, this is like a node, this is a parameter. If, quite similar, we take the round bracket, transfer it, and the operator is in the round brackets. In closure, almost all these expressions return. That's why we would not have to write return. And this is symbol x, value 1, the value of the variable. So we can substitute 1 by 2, and the result will differ. So how can we announce the function? There is a specific formula, defn, the name of the function, these square brackets. I will explain you what it is. Here we have arguments, so you can place a common, but you do not have to place it. And this is the body of the function, a and b, and here we are calling. I hope that you can understand it now. In the beginning, it's quite difficult to get used to these brackets, but after that, if you count the number of square brackets and punctuation marks in your language, you will understand that there are fewer syntactic structures in closure, and it also gives you an opportunity to fulfill structural editing, so you can remove a lot of things, you can shift them. So we announced the function and we called it. Let's go on. Closure is very small. It is the first function to host. That's why, first of all, we need to understand that these functions are taken from host, and if we are using GM, we can see a primitive GM. So this is a string from Java, and there are several special strings. So there is a string that starts from colon. This is a keyword, and keywords are used as keys for hash maps. And here we can use MySpace. And also there is a symbol. So when you write it this way, Closure is trying to resolve it, but this is a primitive data type. This is a string, and it is used to store the names of functions. So these were primitive things, and there is a small amount of inbuilt data types. Vector in square brackets. So I guess that you are well aware of this array of vector. We announced it, and here there are a lot of operations. For example, we can take an element, and we can add vector. Here, we can take everything apart from the head. We can remove the last one. There are a lot of functions here for working with vectors. And there is a list. It should be written in this manner or in this manner. Actually, by writing code as a data type, you will not work with it frequently, maybe only when you write macros. But in principle, this is a collection, this is a sequence. So here you can see round brackets, and this is a list. This is the essence of the list, because we have data in the brackets. That's why microsystems, the opportunities of extending the language, that is quite natural for Lisp and Closure. But actually, quite frequently, we do not write macros if we do not really need it. And speaking about this list, we can execute some operations, we can add something, it is added in the beginning, and there is a specificity here. But when you write lists, this is a list as well. The first symbol is ANS, the second one is L, and Closure executes it. Okay, so here we can collect code. This is the way you write macros, so you can collect your code. There are sets. This is an ordered collection, an ordered sequence where all the elements are unique. For example, we can add a string, nothing is changed. We can remove number 3. There are dozens of functions for working with sets. And of course, the queen of our data structures is hashmap. So this is an we can put a comma here, we can write it down this way.
We can add thousands of functions or dozens of functions, or we can remove the key, we can merge two marks, a lot of functions out of the box that help you operate with these structures. All these structures, when you change them, you have a semantic of copying. When I did merge here, I got hold of the new map, but the old map remained as it was. You have an illusion that every time you get a new one, but it's a tricky thing inside. It looks like a guide, and it costs you almost nothing. You can write in the functional style because all your major data structure are mutable, so they can be clean. It may look that it is not so important at the start, but when you start working with it and realize how much nicer it is to operate with immutable functions, with clear functions. You may face concurrences as well. At some point of time, Alan wrote about epigrams in an article, and he collected a set of proverbs, and he said it's better to have one structure and 100 functions on top of them instead of vice versa. In Azure, we have 4 data structures, 500 functions, and 100 macros out of the box in order to work with data. Here we see the range. We filter and get 10. Double arrow is a macros. You can reverse it. It makes a simple thing. It takes the first expression, put it in the end of the second one, take this expression and put it in the end of the third expression. This is how it works. It's better to read it because it's a stream of ranges. So don't be afraid of this macros. This is called shredding first. The next expression is inserted into the end of the following expression. So we can work with the map. We have map with an address, and inside there is an update. Again, a lot of functions that help you transform data, change data, run across data. At this point, so we have learned 80% of the system. We have primitives, basic data structures, and clear functions on top of them. 80% of your code, nothing in excess of this. And this is the wonderful simplicity of Azure. There is one more important thing, which is REPL-driven development. What you see is that I value the code, I perform it. Everybody is saying that in many languages there is REPL, and it is imperfect, but it's a tool with which you work. In the morning, you launch REPL and develop a program in the same fashion as I did. So you insert expressions, and you'll further see how it is being done. But for this to work, you need to know several tricks. For example, when we announce a function, a very simple function, like this, for example. This defen is a macros. We can expand it, made of def sum var. Var is a mutable structure, is a reference type of data, and it provides a mutable value. If var is without any special signs, the system tries to get hold of the value, but we can use this magic sequence. And why do we need this mutability in the world of clean functions? For the following purpose, to be able to reload the code quickly. So we can redo it. So, comma EE, I'll explain what happens. It takes this expression and sends it to runtime. Runtime sends it over, and the sunvar shows a new implementation of the function. If we touch it, we see it's new, and then we get a hot reload of the code under the commands from your system. If a different function was sent to this variable, it was in the Russian version, then we redo it to the English version, and then check the function, we see that it has changed. So the program is made of clean functions which can be reloaded. There is no state. The program structure is based on mutable structures, on references that help you reload it easily, and state is somewhere on the side, and you have a chance to reload the hot in runtime. If you have a look at other languages, dynamic languages even, it will be exactly the opposite. The code is very deep inside, it is immutable, your functions operate with mutable data, and there is a state somewhere, and there are objects, and this code cannot be reloaded without hacks because of the blurred state and for other reasons. But what we did, it worked very simple. I have Emacs with simple plug-in. It takes an expression, sends it according to a certain protocol to nREPL server. The operating server just takes the string with the code, runtime evaluates it, and then it returns it. So the whole point is the on-wrapper server. It is smart. That's why IGE support is quite a simple task. A few words about macros. I wanted to explain this. These are data. We can print this code, we can run through it as a structure, we can mention a type. Also, you can modify the code if you decide to expand the language syntax. You can use simple functions for that. This is the end of explanation of Quazure. I think we spent about 5 to 7 minutes. Let's see how we work with the database from the closure. So we can use a thin wrap for JDBC. Let's get a connection string first, the one reading the variable. Let's have a look what we have. Here, I have Becker Compact. Launched with Postgres 13. So I think we can reach all this. A thin wrapper on JDBC helps us, wait a second, send a simple query. We'll go to the database and get this value 1. We can find something interesting, get a list of all tables, for instance, through the information scheme. Someone in Twitter asked how in Clojure we work with SQL. Well, we have uniform runtime here, from which we can send queries. So we can create a table through execute, create a simple helper. Here we have IB, serial IB, data JSON. When we have JSON in Postgres, we would like to have dynamic data structure. So here we can do the inserts
Это как бы цикл for, каждый раз вот новый
This
юзер
is
берется из этого
cycle
списка,
4.
и мы их тут вставляем. Тут ничего удивительного.
So we do insertions, nothing unusual.
Вот. Ну и в частности выбрать, например, из базки, вот мы видим этих ребят.
So we see the guys here.
Ну вот мы можем смешивать, например, наш средний метрос. Я говорю, что в Quazure есть сотни функций, чтобы
in Quazure we have dozens of functions.
Получили список, по списку пробежались,
So you can get hold of the list, get data key, hash map, and look through the results.
Можно прямо вот так вот SQL name получить.
You can get it with SQL name.
Вызывать. Вот. Тут, наверное, как бы, ну, можно передавать параметры, то есть через
you can provide parameters or transmit parameters
через вопросик.
Through questions. It's important to mention that it's been a while that we decided not to hide SQL behind some forms, frameworks, because the language is quite expressive and business tasks are implemented very well with SQL. So we decided that in our development, SQL should be the first-class citizen, and big portions of applications are written on SQL, although it is not easy to work with the strings and glue the strings. And it is not convenient to change them in the middle. So the business application, 80% of them are generators of SQL queries. Therefore, in Clojure, we use a classical approach. We don't have classes of objects, we only have types of data, and the only abstract that we have is generic data structures. So in this case, we can try to view the query in this form. So asterisk, person, so some constant lines. If we have this hash map, we can use dozens of operations, hundreds of operations, and do what we need. There is a very small library that accepts this data structure and generates an SQL query. So you can play with it here. So here we add a limit. Here we replace it with ID. We can even write a small helper here to accept GDBC line or string. Or if it is something different, it will interpret it like this. Let's do this. It will be useful. I loaded into runtime this function. So we can make a query, select asterisk. This is end block, a key that is not used. PG format. Copy the query and have a look at it. This name key was used as a comment.
То есть пока мы оставим за скобками, как этот DSL реализован, но на самом деле он очень...
We will not explain how it is implemented, but in fact it's a small one, it's one file which implements conversion of this data structure into a string, and this happens quite frequently. We have quite a few libraries, and they replace huge ORMs with a lot of dependencies. So this is a one-file library. So it's a business card of Clojure. So instead of gluing data, we're now moving to data structure. We can write a function. So here we add values. Like this, for example. So we can transmit parameters. Hash maps are written in the reverse order. So instead of withdrawing the keys here, we write the reverse order and receive those variables.
И здесь мы начинаем динамически строить запрос.
And here we start building a dynamic query. It is enough to ignore things here. If nothing is generated here, then we write a search function. It shows a query that we get hold of, and we can even add an SQL. So we reload the function and see the output. So this is the data request, this is the SQL with the parameters, and this is the outcome. So we can use different parameters, and I think you can feel this fast speed, and you see the SQL as a data structure here.
Да, ну вот как раз, например, когда нам становится больно клеить строчку, когда мы
So when we stop liking gluing the strings, we want to modify our query in various places. Let's write a function that performs the same query, but at the same time, we want to get count. To get count, we need to modify the query and change this section.
Также, например, мы сразу можем кинуть
Also, we can do analyze. Of course, it depends on a certain parameter. Analyze will be modified as a modified query. Therefore, we get 3 queries out of 1. And let's see what we get. So this is the count. This is analyze.
Опять-таки, вот, то есть представление запроса в виде структуры данных позволяет его потом...
So a query in the form of a data structure can help us modify it somewhere in the end, to reassemble it along the way.
Так, вот этот наш язычок, который структуру данных как бы...
So this language that ensures data structure, it can easily be expanded. For example, we see repeatable or repeated patterns. JSON-B convention data. So we take something from it through the operator, through arrows. In this case, the format generates this, and we see that this pattern is repeated. Let's expand it and add 2 arrows that would hide this repeated structure. It would be a sort of a macros. Multi-met function. I will not go into detail of this, but this is how we do polymorphism in Clojure. We enter a new character and say that this expression should be used. So you see repeated strings. So our query can now become much shorter. Even if you repeat I like, so this is wrapped, and the whole code receives more expression. So, and now we can deploy it. So you can remove excessive code by doing this. Make queries and build high-level API by introducing something new. So it costs you a few strings. The library itself, for example. Here we see a lot of structures, constructions, we see tests here, and the outcomes. So try to perform them. If you are tired of writing JSON-B built object, you can create a so-called macros. Because it's a data structure, we can turn some portions into SQL, and then they will compose themselves into something more sophisticated.
Okay.
All right.
Вот как бы в этот момент где-то наступает, если вы начинаете мыслить данными, и все превращаете в
So
данные.
at this point, when you start thinking in terms of data, you have enlightenment and you start think about model-driven, how to describe what I want in a declarative way and write an interpreter or an engine. It is great to describe it with data, but when you write external or internal DSL, it takes 1 or 1.5 interpreter. But we have a design, for example, for creating a table, which is assembled into such an SQL. This is a data structure. Let's assume we have a description in the form of a JSON scheme, and we want to generate a table according to JSON scheme. Quite simple. Well, these may be types in Postgres, and out of this map we can get, if we have string in JSON scheme, then we can see that it is a text in Postgres.
Now we're writing generate columns function, and we're using reduce to collect these columns. So we've written this function, and by default we inserted ID here. It can be executed here, so we did it, and now we see a piece of the result we need, a piece of this table. After that, we can check our scheme and gather the final SQL. So this is a function. Now we can call this function in our scheme to see the result. Here it is. And actually there can be thousands or hundreds of these instances. You develop this JSON scheme, and after that you checked it and created the tables. You called exact, and this is the table. It is empty, but it has appeared. Another example of these consequences, it seems to us that this step is insignificant, but it has its consequence. Now you can analyze your queries. Data structures are regular. You can check them. For example, how can we offer indices by query? This is a naive implementation. We have a query here, and we want to write a function that will offer us to create an index. And for the index, we have this data structure. It compiles here. So we write the statement of the index. We receive table expression. And now we will take this part, analyze this expression, and offer an index for it. This is the key, and we will use it as a part of the index. So we selected the name of the table, the key. We added index here. This will be index name. We started collecting the structure. And after that, we looked at expression. And if we have an equality here, we enter expression here. If there is I like, we will insert gene here, and we will correct expression a bit. And we will get the index. So let's see it. So now we check the whole query, and we received two statements. This is just a demo. Of course, in your real life, you will go much further, but it's important that you are moving in that direction. So you are trying to think in a generic manner. I already mentioned that this is SQL, and SQL is represented in the form of data. This is just a part of demonstration of business operations that merge insurance. CTE is used, and in one query, we execute a lot of operations without loading the base. Without further transactions, we prepare it in the form of a single query. This thing can be divided into pieces because now it's quite easy for us to collect functions. We can reuse it in search, for example, in indices. So this is the function. It's quite complicated. It seems complicated, and after that we can collect SQL. We haven't touched the base yet. Another example, a bit more difficult for you to understand the way production code looks like. So this is a smart operation called patching in Postgres, and it actually confirms why we do not hide SQL. So we want to patch without concurrency problems, or without touching the essence itself, and I do not know how you can wrap this SQL. There are a lot of commands here, and writing specific wrappers for all of them is quite complicated. So how much time is left for me?
Ваня, сколько у меня времени?
So how much time is left?
10 минут.
10 minutes.
Ну, прыгнем и посмотрим немножечко уже на такой
Well,
общий пример.
now I would like to show you a general example.
Когда вы читаете существующий код на клажуре, нужно читать...
When you read an existing code on Clojure, you should read it from bottom to top, because actually Clojure reads it from top to bottom and it checks the symbols that were already announced. This is a limitation, but this is a subtlety. It actually let redo work. Speaking about web, this is a small library, and we can launch a server. For example, this is our handler. We will comment it, and writing a simple web server is writing a function that will receive a query in the form of hash map, and that will return the response. So this is the response. This is the server. It will answer hello to everything, and we're starting our server. It was already launched. Now we're moving towards our host. It will respond hello to everything. And it's important to reload this function in Dynamics.
Okay. На самом деле мы тут сделаем чуть-чуть посложнее, тут немножко helper.
Actually, here we will make it a bit more complicated. Here there are a few helpers, and this query will be in the form of hash map. This query string, we will pass these parameters using this function, and after that we will have request. After that, we call routing. This is dispatch that will select specific function that will respond to the query depending on the routes. And here there is a helper. So in JSON, we will transform it in order not to repeat it in every handler. So our dispatch function is quite simple. It uses routing that is built on data. So we describe routes by data. This is a sitemap, and if this is a method, then the function that will be responsible for this method, and if this is a string, then we call, for example, big tables. It will mean that this is a way to the inbuilt hash maps, and the routing itself will divide this pathway and look for the necessary node in hash map. So it has divided it into steps, and after that it looked for it on the way to hash map. These are the steps. They can become parameters. So this is a parameter. Anything can be presented in parameters. These are our routes. All the library for routing is from one and the same file. It allows us to transfer this query, and it will find the node in this hash map. So we can select it from here. We can check it, and here it answers us. There is a bit noise here, but it found this function, this select function, and in MS table parameters, we can see the necessary parameter. So this dispatch function is quite simple. It looks for the function that can be moved further. It selects parameters and calls this function, and it returns the response. And, for example, let's check our roots. Well, big tables, for example. This is a classical query for 10 largest tables. So these are the data, and the handler itself selects query and returns the response. We don't even need to enter the browser because this is a function. We can select dispatch function from here directly and see the response. If you do not believe me, we can enter it, big tables, and here's what we have.
И таким образом, дальше вот там чуть поинтереснее, например, какой-нибудь динамический.
And after that, it's a bit more interesting. Dynamic select, for example. No space in the table. So what does select do? In our case, it builds this query. So it glues new space with table, builds the query, and executes it. So, for example, here we select tables, formation scheme and tables, or we can select our pub that we developed before. So it responds to us. And after that, it's possible to write Postgres over one day. I think that many of you have seen these products. They have dynamic parameters.
Вот у нас пришли параметры, давайте такой самый наивный.
So we received the parameters, and let's select the most naive variant. So here we write parameters.
У нас будет как бы эта секция V, в которой мы собираем ключик,
We will
которые пришли из параметров.
this section where we get the key that came from the parameters. After that, we use hashmap assert, and that is equal to key V. So this is very primitive.
Ну и, например, вот здесь у нас по ID-шнику давайте поищем.
And, for example, here we can search for it by ID. We can state that question mark ID is equal to 3. So we forgot transmitting it actually. So it's necessary to write it here. We reloaded it, and here it was filtered by 3. Now we removed it. So let's select 5. Of course, this is just a demo, but I hope that you can see what I'm entering. I guess that you understand the meaning. These are the parameters. And we only had to write 2 or 3 strings for it. At first, it looked quite crypto, but after that, we get used to it. So we called reduce function, selected parameters, and we started gathering this structure of query. By default, this is an equality, but we can get a smarter thing. We can parse parameter at I logged more or less, and it will be interesting for you to reproduce Postgres. And this is the way we develop it. The things that you are saying right now actually is not really different from the way we work in production. So, but the only thing is that we use a test-driven. Well, in this case, it's possible to call directly this dispatch function, and if we write a test, we write SR. Status, for example, 200, and what we have inside. Our one file library that lets us match this data. So you start writing these points, you open them with tests and get them from REPL. You fix them and you return. I guess that now I can finish my presentation and I'm ready to answer your questions. Well, first of all, I would like to thank Nikolai for his interesting presentation, and I apologize for mixing you up with the USSR Prime Minister because your family names are very similar. I would like to remind the participants that you can ask your questions on the chat if you want to ask a question of the speaker. And now I would like to move on to Q&A session. So probably I did not understand you correctly, but taking into account the working with DSL and data structure, is it right that when you work with Clojure, the objective of Coda is to write a pseudo-array for working with data that will be written on functional language without data mutability? Well, that's an interesting question. It's difficult to call it an OR-M because we do not have any objects, we only have hash maps and primitives, but calling it a library that will help you put this query on a higher level, hidden boilerplate, yes. In Clojure, well, you've seen actually this roots in web, SQL, and actually everything can be expressed in data if you want to do so, and you write several interpreting functions. And what is good about data compared with inbuilt DSL probably I mentioned it as well. Data can be interpreted differently. So you can write a lot of interpreters. For example, on JSON scheme, I wrote an interpreter that builds tables. And if you realize this aspect, you can describe this model, your DSL, and by it, you can do anything. You can generate documents, you can generate tables, you can analyze queries. So when you use this metadata, this model data, you can do it. And after that, an enlightenment comes. You start seeing the metrics, the models, and the interpreters. All your program is a set of models in the form of data and a lot of interpreters. And I would like to ask a question on my behalf. Pure function is good. Java transaction architecture. Have you tried using it? For me, it's interesting. How is it possible to use it in JS? I mean, binary transaction. Or, speaking about some libraries, how can you use it with a library? And how difficult it is? Well, it's not difficult. Actually, we can just use it in Java. A lot of Clojure libraries are just a wrapping on Java, which we've just seen JDBC, but it's possible to make it more beautiful than Java has it, and we can discuss it. For example, if you manage to express your transaction in the form of data, in the form of intent, then it is possible to use a lighter double-phase transaction if you can write your logic in the effect that hadn't been applied yet, or you can make a rollback on this effect. In that case, you become more free. And it would also be interesting if you could compare the option of data working offered by Clojure and just joke and criteria. And what are these? These are TPE view of queries. Well, I can compare it. In each of these operators that we've just seen, it's possible to wrap them into a specific function or a type, providing validation, but it will take you a lot of time. In this case, this library that I've showed you, that does everything, you can just open it right now. Can you see my screen now? Yes. So, the whole library, all these constructions, it has 1,000 strings only. Actually, we can remove this then. This is 700 strings in one file. And it's easy to have an extension for you when you use 2 or 3 strings. If you see boilerplate that is repeated in SQL, you can extend it. So this is the issue of efforts in Clojure. We work inside the metrics. We only have these functions. Another important aspect is transparency, being open. Sometimes you merge DSL and this generic data can be mixed. So you start merging DSL, and at that point it might happen that SQL is mixed with security checks, for example, and open data can be mixed easily, but specific type data are not mixed. And using the example of DSL that we used in web, I can show it to you.
Вот, у нас тут были роуты, так, например.
So here we have routes.
Я бы, например, мог придумать, захотеть сделать такую штучку, сказать, что вот у меня тут есть
And for example, I can say that here we have a query,
get, и здесь просто положить запрос.
get, and here I can place the query.
И придумать еще язык там какой-нибудь.
And I can devise a language
Таким образом, вот я вообще
that will give me the parameters. So this is declarative. Here I mixed two DSLs, one for routing and the second one for our queries. And I could also add here security check, access policy, and DSL for access policy can be used here as well. And the interpreter is written directly generic candle that takes this node of these routes, selects a query, and executes it. Or it can call access policy. Unfortunately, in specific type languages, you will not be able to mix up these things. So at some point, when you want to mix it with something, it will not be mixed.
So the idea of dynamism and openness is good. So we can let the user do this and keep it in Postgres, and the rules will be loaded from the database. There is a joke. Any system strives to become an interpreter. It becomes smarter and smarter. The user wants to add additional settings. Well, you need to learn to limit yourself. Well, I remember a report on Postgres for hipsters. What made you release a new version? No, JS on Closure, we've never done this. For hipsters, there was a Java conference, and I spoke their language, the language of hipsters. As far as JavaScripters are concerned, they're all invited to get tried. This will be a new turn in the spiral of development. Where there were no Java developers, JavaScript developers, JS could have turned into Closure if it was minus minus, but it is now being turned into plus plus. This happens with many languages, unfortunately, and which expands capabilities without limit. But this is a unique situation. That gentleman took 2 years off and wrote this language. As far as Closure is concerned, in the past 10 years, there has been no breaking change. So the author wrote the language so well, there was no need to introduce any breaking change. So they update libraries, but they don't include anything else in it. Well, maybe Java can be compared with Closure. All right, I think you can move now to the spatial chat to interact with the speaker. So there is a button indicating the spatial chat. So please move there. It will not be broadcasted, but you can directly talk to the speaker. So this is the end of our Q&A session. Thank you for the questions and answers. We have a break till 11:45. See you then.
Мы возвращаемся. Меня зовут Фролков Иван. Мы продолжаем нашу конференцию.
So we're back. My name is Frolkov Ivan. We continue our conference. Any participant can create its VTAP, press the button, and fill out the form. If the program committee confirms your subject, then your meetup will be confirmed by the steering committee. And now let me introduce our next speaker. And our next speaker is Igor Kosenkov. I'm engineer of Postgres professional. Today we will build a fail-safe cluster with a CRM utility. I once asked Google or Yandex how to create a fail-safe cluster with CRM, and it didn't answer anything. Well, actually it did, saying that CRM is a customer relation management. So it's a way to control management, to control customers, manage customers. Although I was looking for something else, cluster resource management, not customer resource management. But if you search in other search engines, PCS utility, you will find a lot of information, several articles on Haber, including my article, Cluster plus Maker car sync, without hard launching medicine. Well, I believe CRM doesn't receive enough attention, and I decided to cover this gap. There are operating systems where you use CRM only. There are operating systems where you use PCS only. And there are operating systems where you use both. The reasons for that, for certain developers to use CRM or PCS, are not known to me. I can only suggest that it all depends on dependencies. PCS depends on Ruby packages. CRM depends on Python. As you know, Python is everywhere. At the same time, Ruby is not always and is not everywhere. Moreover, there are some difficulties with certification of Ruby packages in the operating systems out of the list of Russia-made operating systems. CRM PCS utilities have something in common and have differences. The operating systems that they are used in are listed here. And you can see the commands on the screen. The similarity is obvious. It is start-stop cluster. It is configure show and creation of certain resources, cleanup, and others. There are differences, however, between those two utilities. So the first difference that you will see as you work with CRM or PCS is, well, the first phase is cluster initialization. To initialize a CRM cluster, you need just one command. To initialize PCS cluster, you need two commands: authorization, exchange of keys between the cluster nodes, and creation of a cluster with a PCS cluster setup command. In stop-stop cluster functions or commands, start-stop cluster command can be performed on one node only in CRM, while PCS minus all. There are other differences, for instance, in the update of various resources which you have created and which you work with. For example, you have a setup cluster, and when you want to change a resource, for instance, add an option or change timeout or add a certain parameter, with PCS or in PCS, you use update resource and then indicate the name of a resource. It is different in CRM. Here in CRM, you launch edit command, and you have the full configuration file available, and you can immediately change not just one resource, but the full cluster, make any changes you want, and when you leave this utility, or when you leave the edit mode, the changes will apply immediately, instantly. Moving on, there are other differences. PCS utility has web interface. CRM does not have web interface. It is available only in commercial versions, Linux Enterprise Server, for example. So what are we going to do today? And what is the test bench? What does it look like? The test bench or test stand is made of 3 nodes. So you see a 3-node cluster, master with synchronous and asynchronous replicas, virtual PRS, and client connections to this cluster. Here you see a test stand, which is 2+1 cluster, where we have one node which plays the role of a master node, and the second node is a synchronous replica, and the third node is the voting node. What do we need? We need for each nodule, well, operating system is installed on each node, CentOS, version 7.9. You need to add repositories. Here you have 2 options. It could be either extra OK repository or OpenSUSE repository. We also need packets with placemaker, CRM shell, and synchronization configuration service, CarSync, or CSync it is called. In addition, the nodes have packets or packages. Postgres Pro Standard, version 11, DBMS. We don't need to tie ourselves to a given version because CSync operates with the previous versions as well. So there are no preferences, but today we will use version 11 just for the sake of this exercise. As we set up the cluster with CRM scripts, there is a call for ksync 2. This is a special utility to synchronize configuration clusters in the file. In CentOS, this utility, once you install it from the package, it will not work because the package does not contain 2 files. 2 files are missing, which are responsible for the launch of this system. Unit and 2 files. And it took me some time before I understood it, understood why the synchronization service did not work properly. So eventually I understood it. And during this exercise, I will tell you what changes you need to make this work. It's important to note that if you work with a commercial version, this utility has been set up and it will operate properly. Because today, we rely on CentOS operating systems, and all setups were made in this operating system. I cannot be sure that other operating systems that you may be working with, Debian or Alt-Linux, I'm not sure this utility will work immediately. I'm talking about CSync. I'm not sure it will work immediately and properly. So we will consider 2 cases for that purpose. The first case is when you fail to handle this utility, it doesn't work, but it's not a big problem. You can create a cluster without using this service. Finally, this utility is needed for original setup. You create a cluster once, set it up, and then it operates. If you fail to set up case C-Sync, you'll have to repeat some actions manually, and this is not very painful. You'll just copy a couple of files and perform several commands, and I'll show you which ones. And the second case we're going to consider is when you set up C-Sync, it works well, and in this case, you can initialize the cluster from one node, we can add nodes, we can remove nodes, and this will be a more beautiful solution. You will see this. Now about the settings. DNS is needed, or ATC hosts. They need to be set up to have node resolving between clusters and nodes. Additionally, you will need, if you have a virtual machine, you need to create an account for the user in hypervisor with appropriate rights. The rights are needed to turn off or reload the virtual machines. If you have hardware servers, not virtual machines, if you have hardware servers, you will need to set up an account in your hardware servers for IPMI plate. What else? You will have to ensure traffic transition for hypervisor, for virtual machines, ports and protocols. You will see the ports and protocols, and you need to ensure permission in the firewall for transmission of packages for case C-Sync 5432, and to connect the administrator per protocol, per reference protocol. So to set up a cluster, we will need the following resources. VIP master is the resource name. It has an IP address. PG resource has PGSQL. And the fencing agent, there will be 3 of them for the 3-node cluster, called fence node 1, 2, 3. They are called fence verse because the hypervisor that works here and with which I launch virtual machines, they are compatible with fence verse. Now let's move to setting up the 3-node cluster. I intentionally omit installation and initialization of Postgres packages. You can do this as you like into the appropriate directory and use the settings that you need. The only advice, initialize with checksums turned on. At present, node 1, we have Postgres installed and the database is initialized. The changes that I have introduced are minimal. I'll show them to you.
Как видите, здесь просто
As you see,
слушать все интерфейсы, все адреса.
Here we say listen all addresses, and also for convenience of logging, I turned on logging collector, and I also included the minimal number not to initialize archive and restore commands. They're turned off for a while. I turned on the minimal number of wall keep segments, 10 of them. Let me show you the settings. So you see that or there are no overly complicated settings. So I haven't done any of these. So this cluster will operate with Postgres out of the box. Let me also show you the access file. Here I provided permission for all connections and security settings, all authorized, but we are not going to discuss them today. Moving on, what do we need to do? In the other two nodes, we have node 2 and node 3 with your database, to make a copy of your database. And for that, we need to launch on node 1. We need to launch Postgres on node 1. So it has been launched. And then copy the database by means of base backup utility on node 2 and 3. So it has been copied on node 2 and node 3 now. Next step, we need to install Postgres because Postgres should not be launched automatically and independently. All Postgres control is performed through cluster software. Just in case, let us verify whether systemd unit Postgres is turned off. It is turned off. It hasn't been launched, which is the way it should be. So this is the end of the setup of the Postgres for the cluster. Then we move to the setup of the cluster itself. Cluster initialization is performed on one node. First, let's consider the more difficult case when for some reason we fail to set up the synchronization server. But we want to set up a fail-safe cluster. So to do this, we initialize the cluster in one node, the node we are in, by means of initialization command. As you understand, this parameter name is the name of our future cluster. And here we have node parameters and nodes participating in this cluster, and we don't use the configuration server. We set up the cluster made of one node yet, for the time being. With CRM on utility, we verify how the cluster operates, so it has been launched and it is made of one node. Next step. Now we need to copy the authorization key and configuration file for CarSync. The previous command in cluster initialization command. Well, it calls two files to appear, the authorization key, and we can have a look at it.
Файл конфигурации
CSync authorization file, we can also see it.
Посмотрели.
So we've seen it, we've checked it. Now we need to copy those two files onto two other nodes. To do this,
мы их скопируем с помощью
we will copy with SCP utility.
Копируем авторизационный ключ и файл
So we copy the authorization key and csync.com. We copy it onto the second node. The system requests a password. We do the same with node 3. Enter a secret password. I will not verify it. I'm sure all is copied.
And after that, for the demonstration purposes, I will launch the cluster monitor on the first node. You can see that now we have only one node, this node 1. And on other nodes, node 2 and 3, we need to launch the cluster on these nodes. And we execute crm cluster start command. So what do we have now? On the first node, the monitor was launched, and it shows that the second node is present. On the third node, we do the same thing.
Смотрим на первом
We
узле.
check it on the first node.
Все, вот у нас начальная инициализация кластера на этом.
So this is the initialization of cluster. It has been finished now.
Я думаю, что каждый
I do not see any difficulties here, and I think that everyone can repeat it.
должен сказать, что по
And I'd like to mention that by default,
у вас кластер будет работать
during cluster initialization, cluster will function in multicast mode. Not everyone is satisfied with it, especially speaking about network administrators, and probably a better solution is to use and set your cluster in unicast mode. Now, we will divide this cluster that works in multicast mode, and we will assemble it in unicast mode. It can be done quite fast. So I enter this string, and I can comment on it. We stop Kresenka service. After that, we delete all XML states and configuration from cluster directory, and after that, we delete everything that is present in Kresenka service directory. This is Kresenka conf and authorization key, so we have deleted this. And we do similar things on the second node. No, I did not copy the right thing, now I will repeat it.
На третьем узле я тоже это повторяю.
I'm repeating it on the third node as well.
Все, у нас кластер
That's
перестал
it.
существовать.
The cluster has ceased to exist.
Создадим кластер с помощью
Now, let's create a cluster
в режиме unicast.
that works in unicast mode. For this purpose, we need to add
Соответствующую опцию. Она вот у вас
the necessary option. You can see it on the screen. It is quite similar, but here we add
unicast.
--unicast command.
Инициализацию.
We execute the initialization,
Кластер состоит из одного узла, то
and this
никаких
cluster
вопросов, никаких,
is made of one node.
скажем так, запросов
That's why,
паролей и
there are
авторизации у нас не будет.
no requests of passwords
Также
or
у нас после
authorization.
этой команды появится кластер,
After this
состоящий из
command,
одного узла.
we will have a cluster that is composed of one node.
Подождем.
Let's wait.
Готово. Проверим.
It's ready.
С помощью
Let's check it.
монитора кластера, что у нас
We
получилось.
use cluster
У нас
monitor to check what we have.
состоящий из одного узла.
Indeed, the cluster was launched and it is composed of one node.
Поскольку этот кластер работает немножко по-другому,
This cluster functions a bit differently, so we will need not only to copy the authorization key and config files Kresenka, but also we will need to edit this config file preliminary.
выбираем, открываем
For this
этот файл
purpose,
с помощью
we
любого
open this file
любимого редактора. У меня
using any editor you like. My favorite editor
боюсь этого слова edit.
is Microsoft Edit.
Я открываю этот файл.
I open this file,
И вот он перед вами. Здесь, как
Here it
видно,
is, in front of
в списке
you.
узлов у нас только лишь
In
один
the
узел.
list of
Нам
nodes, we have
необходимо
only
сразу
one
добавить
node,
еще два узла.
and we
Для
need
этого
to
мы
add
это,
2 more nodes here.
копируем,
So we copy
вносим
it,
необходимые изменения.
we introduce the necessary changes,
Дальше. То же самое делаем для третьего узла.
we do a similar thing for the third node,
Да, и вот здесь у нас есть у нас такой параметр, поскольку кластер у
and
нас
here
состоял из
there is
одного узла,
this
нам
parameter
необходимо
because this
для
cluster
голосования
was composed of
указать,
one
что
node,
при
so
голосовании ожидается при полном
we
кластере
need to
ожидается
specify
3
that the
голоса.
voting, in case of full cluster, will contain 3
поскольку
votes.
Racing запущен, ему необходимо пересчитать
PGConf
конфигурацию.
was launched, and it needs to reread configuration. We do it with restart PGConf service.
Посмотрим, что у нас изменилось.
So what has changed?
Сейчас он немножко подумает. И
Now it takes some time,
узел первый у нас будет в онлайне,
and
а
the
два
first
других
node will be in online, while 2 other nodes will be switched off. They will be in
вот это
offline
произошло.
mode.
То
So
есть,
it has happened.
В данном случае
In this
я
case,
хочу обратить внимание,
I'd
чтобы
like
вы
to
вспомнили,
point
что мы
out
видели, когда
for you
делали
to remember
кластер,
what we saw
работающий
when
в
making the
мультикаст.
cluster
У нас не
working
было
in
этой
multicast
строчки,
mode.
которая говорит о
We
том,
didn't
что
have
у
the
вас
string
еще два узла,
stating
которые в
that we
офлайне.
that we have
Эти
2 more
данные
nodes in offline.
Racing считал из конфигурационного файла.
So PGConf read
Значит,
this data
мы
from
отредактировали
config file.
PGConf.
We
Теперь
edited
нам необходимо
PGConf
совершить те же самые
file.
действия, то есть скопировать
Now
ключ
we
авторизации
should execute
и
similar actions. We need to copy authorization key
конфигурационный файл.
and config file.
Для этого просто с помощью утилиты scp
For this purpose, we use SCP utility
второй и третий узел.
and copy it on node 2 and 3.
Копировали и третий узел.
So we've copied it and node 3.
Копировали. Соответственно, для наглядности я запущу монитор на первом узле.
For the purposes of demonstration, I will launch the monitor on the first node, and on the second node, I will launch the cluster.
Смотрим, что говорит монитор.
So let's check it, what monitor
Монитор
says.
сказал, что второй
The
узел
monitor
появился.
stated
То же самое
that the second node has appeared.
запускаем кластер на третьем узле.
Now, while launching the cluster on node 3, let's look at the monitor.
Все, в онлайне 3 узла.
That's it. We have 3 nodes in online.
Настройка или инициализация кластера
Now,
первый.
the setting or initialization of
Вот. И теперь
cluster, part 1,
посмотрим, какие
has
же
finished.
преимущества и,
And now,
скажем так,
let's look at the
удобства
advantages
нам дает,
and
сервис
conveniences
организации
that we can get thanks to
который здесь
PGConf
настроен и который здесь
synchronization config service. It was set here, it functions here. So why is it beautiful? Why is it great?
разберу.
For this purpose now, I will deconstruct the cluster. So destroying is easier than building.
Так. Выполняем серию команд. На
We
каждом узле.
execute a series of commands on every node.
Все, кластер мы разобрали. И
Now we
теперь
have deconstructed the cluster.
мы запустим или
It's time
проинициализируем
for us
с помощью
To initialize the cluster,
с помощью утилиты, вызова утилиты cosync.
calling cosync utility. And for the purposes of demonstration now, I will set the initialization of cluster for 2 nodes. And after that, I will add node 3.
Запускаем.
Well,
Сейчас то, что осталось, скажем так, за кадром, происходит все то же
so
самое,
what is left behind the
что
scenes?
мы делали.
It's quite similar to the work that we've previously done.
Генерация пары ключей
We only add here the generation of several keys. These keys
узел.
are transferred to node 2.
Конфигурируется,
After
сервис
that,
cosync.
cosync service configuration is in process.
Этот сервис,
Its configuring is needed for the service
всегда поддерживал в актуальном состоянии,
to
конфигурацию
update
на всех узлах.
and
Это
maintain
рассеивание
configuration on all nodes relevant. This is corosync.con, authorization keys, and other things.
Требуется один раз ввести пароль.
Now I need to introduce the password once.
Есть какие-то сообщения про firewall, что он не может добавить и
So there are some messages about firewall. It cannot add and permit, but this is for firewall D service that had been launched and that functions. Now it is off, so we do not have to pay attention to it. So using one command, and I would like to repeat it, here it is. Using one command, without any additional actions, we have launched the cluster that has 2 nodes. Here it is. This is the cluster.
Красота состоит в том, что
After that, we can see the beauty. The beauty is that we can add another node on the fly. Here, I made a 2-node cluster to add the 3rd node. So, we go to the 3rd node. It is outside the cluster now. I want to show it once again. And we execute crm cluster join command. In cluster node parameter, it's necessary to specify the name of the node that is already in the cluster. So we execute it.
Никаких вопросов нам не задавали, а теперь посмотрим на
We
монитор.
haven't been asked any questions. Now let's look at the monitor of cluster state.
Запущены и
You can see that 3 nodes were launched and they're functioning. And in the same manner, we can delete a node from this cluster. For this purpose, there is crm cluster remove command. So let's remove this node. And here there is a special aspect. If we want to remove the 3rd node, on the 3rd node, it will not allow us to do so without option force. And here there are 2 variants. We can specify this option --force, or we can go to an existing node in this cluster, apart from node 3, and write that we want to remove this node from the cluster. So it was removed, and the monitor shows that now we have 2 nodes.
Ну, в общем, в этой части, наверное, все.
I guess that's it for this part.
Мы сейчас... я должен также сказать, что
And I would also like to mention
кластер можно также
that this cluster can be initialized in unicast mode, as I showed you in the beginning. For this purpose, when initializing the cluster, we need to specify option --unicast. So, when initializing with this option, we will have a cluster that has 3 nodes.
Поскольку нам нужен кластер из 3 узлов, то давайте...
We need a cluster of 3 nodes. So, let's add node 3 here and include it into the cluster.
Добавляем.
So we add it.
Происходят какие-то действия.
We can say something's happening on the background.
Проверим.
By checking it.
Пожалуйста, вот 3-узловой кластер.
So here it is, 3-node cluster.
На этом первая часть инициализация кластера.
Now the first part of cluster initialization is over.
Времени для того, чтобы посмотреть, каким способом.
So I allocated enough time to check the ways and the variants of cluster initialization, and if you failed to do something, please don't despair. Just go on trying, and there are ways to circumvent it.
Давайте немножко поменяем схему расположения. Я запущу
Now I would like to change the scheme of location. I will launch cluster monitor on the 3rd node. So here it is. And on the 1st node, I will execute commands. They will add resources, constraints, the order of launch, the order of arrest, and so on. We haven't created any resource, but cluster already has some default configurations. To see a cluster configuration, there is show command. By default, the Stony mechanism is off. The flexibility indicator is 1. It's not right. We will amend it, and migration threshold is 3. We will amend it. It's not right. So, to change these default values, let's execute the following commands.
Здесь все изменения и создание ресурсов и так далее.
Here, all amendments and all amendments are made, and all resources are created with crm configure command. In this case, we specify the section of features of characteristics that we changed. I specified that we need migration threshold equal to 1, and resource thickness should be infinity. So we introduce it and we check it. And you can see that these parameters have been applied successfully. And we move on.
Значит, поскольку я сейчас в интерактивном режиме ввожу каждую команду.
Now, in the interactive mode, I enter every command and I explain why it is needed and why we need various parameters of this command. So, in the process of entry, our cluster will be launched, and there is some time between these commands, and 2 commands should be launched at once. In that case, we will have an error in the cluster, and to avoid this error, I would like to specify such characteristic of cluster as symmetricity. I will switch it off. So, I need to state that corasync cluster can be symmetric or non-symmetric. Symmetric cluster behaves in the following manner. You create any resource, and this resource is launched on any node. On any node or on all nodes if it was cloned. If this cluster is non-symmetric, then a newly developed resource will not be launched until you tell it where it should be launched. So I use this tricky way to prohibit the launch of any resources that we develop in the cluster. And when I finish introducing all the commands, I will install this parameter in true, and all the resources that we already have in the cluster will be launched without any errors. So, let's check whether this command had been applied. Yes, these are the characteristics of our cluster. Now, this cluster is not symmetric. And now let's move on to resource creation. The first thing that we will need, as I mentioned, the first resource that we need is master view. In order not to lose any time on manual introduction, I would like to copy this command and explain what these parameters mean in order not to spend time on manual introduction. So what can we see here? We use this command to create a resource, master VIP.
It has IP address type, and then we indicate options, operation options related to three actions: start, stop, and monitor. Each of those actions or operations has timeouts, intervals of verification, of launch verification, and additional parameters where we indicate which address we would like to use as a virtual IP address. Under NIK parameter, I mentioned the network interface. In systems or nodes where this network interface is singular, you don't need to indicate which one it is, but better to indicate. So we introduce this command, we enter this command, and then we can see configuration show and see that this resource has appeared. Also, our monitor has been launched, and we see that in the list of resources, we have master VIP resource. Why is it standing still? It's because the cluster is not symmetrical. Now let us create the second resource, which is needed, PGSQL resource, the Postgres itself that will be launched, that will stop, that will promote, etc. I copy the command. It's a short command, only 4 strings. Very simple. What is this command about? Here is the name. This is the type, EJ. Then we list actions or operations. As I said, start, stop, and monitor. Then Cluster Labs, the developer, ensures that we use various versions of Postgres, and in each case we can identify the location of binary PGLs, binary PSQL, and we also indicate where we have PG data catalog, the port, and this master IP parameter is the address, is exactly the address we entered for the virtual floating IP address. Its meaning is as follows. When you launch a cluster, on all nodes, a file is created, recovery.conf. And this file, which is created, it has a string, primary com info. This string means or shows where to connect, where the master is, and also provides a PIN, user PIN for authorization and user replication. and etc.
Используется параметр master IP.
So here we use master IP parameter.
Тип репликации.
Replication type, sync.
Можно указать async, но
You can say
дело в том,
async,
что
async.
с точки зрения идеологии отказоустойчивости и
From the point of view of fail safety and zero data loss, we need to use a cluster in which at least one replica is synchronous. In case of a disruption, they'll be switched to a replica which works in a synchronous mode. And finally, the final parameter is listing of nodes where the resources will be launched. 3 nodes in our case, because our cluster has 3 nodes. I press enter. Nothing happens here. Here, later, we will have some things that you will see, but at present, PGSQL has not been launched. Let us check if everything has been recorded and whether the configuration is seen and the resource is available. Yes, it has been recorded, so that means we can continue.
Далее мы должны сказать, что у нас
Then we need to say that the resource PGSQL has master-slave type.
Мы его обозвали MSPG.
We named it MSPG and PG type. PG type is inheritance of properties of the PG resource. Now we indicate service parameters. The final goal should be the master mode, and we need to indicate on which nodes it can be launched in the master mode, on one of the 3, as we understand. So we launch it.
Мы должны указать, что
Then we need to indicate that the resource of a virtual IP address should always be launched and be located on the node where we have Postgres resource and where it is launched in the master mode. We have a word co-location for that purpose, and by using this co-location word, we say the following. We say that co-location, yes, co-location, then followed by the name of this co-location, could be anything. Info is the short for infinity. It means that with the maximum, with the highest probability and with the highest possible scores, we need to launch master VIP together with MSPG resource. By doing this, we will be able to launch them together at all times. If Postgres stands still, that means the virtual IP address will also stand still. Now the order of launching. Here is the order of launching. It is important to add that as you start the cluster, all nodes, regardless of their previous roles, all nodes will start in the standby mode. They are forced to have file recovery conf on each node, and we calculate LSN, and where LSN has the highest order on which node, depending on which node LSN has the highest node, it will be a master candidate, and it is given the command promote. The command that I'm going to introduce has the service word order, followed by the name of And here we say that first the cluster will promote resources of MSPG, which is the master-slave resource. And after this successful promotion, master VIP will be launched only in this order and not in the reverse, because promote may not be performed while VIP master resource will launch without it, and this will be wrong. So we do this, and it looks like it. It's about the resources. Next step. In any cluster of this kind, it is necessary to set up affinity. Some people underestimate its role, the role of fencing. Speed brain with network splitting, fencing has very high probability of occurring. Let us set up fencing. Have a look at all possible agents of fencing. It is possible to do with the command list. It's obvious, list. Let's see what type of fencing resources we have. We have fencing resources for ILO, fencing resources for APMI, for VMware, because I have KVM hypervisor, we will use fencing, a resource called FenceVerse. FenceVerse.
Так. Да, вот он, нашел. Мы можем посмотреть, с какими параметрами нам его создавать.
We can see how to create it with which parameters. For that, it is enough to give command info, indicate the class of resource, and the name of resource, FenceVerse. Let's see. Here we have mandatory parameters and arbitrary parameters, and non-mandatory parameters. The ones with asterisk are mandatory, such as IP. IP meaning
адрес устройства фенсинга. В данном случае это адрес
fencing device address. In this case, this is the address of the hypervisor.
Это то же самое.
IP address, it is the same, no matter how strange it may seem. Then we have login.
Учетная запись в
This is the account, login to the account
в операционной системе гипервизора для того,
in the
чтобы
hypervisor operating systems,
этой учетной записи
for us to be able to restart or turn off
виртуальную машину.
the virtual machine.
И
So here is the login
юзернейм, который
and the username,
почему-то повторяет
which
вот этот
fully
параметр логин.
repeats
это
this
такой парадокс,
login
я
parameter for some reason.
не пытался
It's
его
paradoxical,
понять, но
and
не смог.
I
Почему у
tried to
нас
understand it, but I
дублируются
couldn't.
два
Why
параметра,
do
IP-адрес
we
и
repeat
логин?
two
Но, тем не
parameters,
менее,
login
если мы
and
введем их один
IP
раз,
address? But
например,
if we enter
будем
them
использовать
only once,
IP-адрес,
for
будет
example, we
один
use the
раз,
IP
не
address and
IP-адрес,
enter it once,
просто IP.
not
Если мы
IP
будем
address, but
использовать
just
логин,
IP.
не будем
So if we use
использовать
login,
username,
we will
то
and
при
not use username,
вводе
then when we enter,
при создании ресурса
when
фенсинга
we create the
будут
fencing
появляться
resource,
ошибки.
we will have
Потому
mistakes,
что
we will have
нам
errors,
необходимо будет вводить почему-то два раза вот эти два параметра.
because we'll have
Я не
to
смог найти
enter
этого
those two
объяснения, но давайте
parameters
будем
twice.
делать так, как
I couldn't find the
нас
explanation for it,
об
but
этом
let's do
просят.
as we are advised.
И прежде чем мы создадим
So
ресурс
before we
фенсинга,
create a
я
fencing
настоятельно
resource,
рекомендую
I
проверить
recommend
цепочку,
that you check
начиная
the
от
full chain,
операционной
starting
системы
from the
виртуальной
operating
машины
system
и
of the virtual
заканчивая
machine, all the way through
выполнением команд фенсинга,
completion of commands of
выполнением команд
fencing,
гипервизора. Для этого я
completing the
рекомендую
commands of the
выполнить
hypervisor. For that, I recommend
выполнить команду,
that you
которая
perform
проверит сразу
the command that would verify
подключение к гипервизору, она проверит
connection to the
права,
hypervisor, connect and it will verify the rights. So here I indicate the address, minus L. L is login of the user. In the hypervisor, this is the password. And here I would like to understand the status of the virtual machine called node 1. Therefore, I use sudo, because the test user should have sudo rights for this command, and I would like to see its status by the status action. So the hypervisor answers that the virtual machine node 1 is on. Also, instead of the status, I could indicate reboot. In this case, the machine will reload. We will not do this, just believe me, it will work. Next step, so we check that the hypervisor is answering and the fencing with the probability of 99% will operate, and then we set up the fencing for our cluster. To do this,
мы с помощью CRM создаем
with CRM, we create a resource.
Называется ресурс, мы его назовем fence node 1, для того, чтобы
fence node 1. This will be the name of the resource, not to be lost in all those nodules. Fence node 1 is the fence for node 1.
Здесь указывается класс, здесь указывается
Here we indicate a class and type of the resource. Also indicate parameters. I mentioned the paradox. We need to indicate the IP address twice. I enter it 2 times for the same user, login and username. It's good that you need to enter the password once. Then I list the nodes for which this resource will work, namely node 1, because we are making fencing for node 1. So sudo is certainly yes, and monitor with a frequency of 60 seconds. This monitor will check the status of the resource, the fencing resource. This interval, in fact, can be increased if you receive messages saying that hypervisor is overloaded. I don't know what it may be busy with, but imagine that this resource becomes the main resource at some point, because a given interval or timeout, so within this interval or timeout, the hypervisor will not be able to respond, saying that your resource is available and operating. So we enter this command. On the display, we see a new resource. It has been stopped because the cluster is asymmetrical. Next step, it's important to mention, it's important to say to the created resource that this resource will be launched on all nodes except for the node that will be turned off. So we say that this resource, fence node 1, which we just created,
скажем так, с вероятностью или со скорами минус infinity,
with the score minus infinity, need to be launched on node 1.
Еще два аналогичных действия мы должны
2 similar actions that needs to be taken
двух остальных узлов.
For the remaining 2 nodes.
Их ввожу без комментариев, потому что они полностью
enter them without comments because they fully repeat.
Полностью повторяют то, что я делал перед этим, только для
what I did before for node 1.
И для третьего узла то же самое.
The same for node 3.
Так, теперь,
Moving on.
У нас тут 3 узла.
So what do we have? We have 3
3
nodes.
ресурса фенсинга.
We have 3 fencing resources. We have the master-slave resource and virtual IP address. All resources are turned off. Now we're ready to launch our cluster. To do this, we turn on those parameters that we turned off in the very beginning, being this, and we also change the role or the behavior of the cluster with, so we change the behavior from asymmetrical to symmetrical and see what happens in the cluster.
We can see that all 3 nodes have launched Postgres resource. Fencing resources were launched where it's needed for the first node, and they're not similar with that of the second node. And now, as I mentioned, the cluster will compile which of them has an older LSN, and the role of master will be switched to this node. Let's wait for some time.
Так, пока мы ждем, что он, когда у нас появится мастер и...
While we're waiting till we have master and it works in a full-fledged manner, I'd like to mention that there is the following way. For example, you set a cluster and it functions great. You do not have to enter the commands that I entered. You can rather write a script that will allow you to push everything at the same time and have it applied for our cluster.
Посмотрите, все то, что я вводил,
Look here.
в виде скрипта.
Everything that I entered is in the form of a script. So the first command was used for cluster initializing, and after that we address CRM configure, and this is everything that I had entered. We use it as a list and push it in cluster configuration, and in the end we state commit and our cluster is launched. Meanwhile, as you can see, in the cluster we have our master on node 1, and according to the rules of collocation, master VIP resource was launched on node 1, and the second node fulfills the role of synchronous replica, and the third one that of asynchronous replica. Let's check it. What if the monitor is deceiving us? To do it,
Зайду в PSQL и выполню запрос.
I need to enter PSQL and execute the query.
Я выполню запрос, у меня тут уже готов.
So, I'm going to execute the query. I have ready queries here. I will execute the query. Select PG is in recovery. On master, this query will give us false because it is the master. Let's ask the replica. Let's connect replica and ask it, is it recovery or not? So it will be easier to write it this way, node 2. Yes, it is in recovery. And once again, let's ask node 3 in recovery as well. So this is a replica. Let's enter master and check the state of replication. Now we are on node 1. So the query gives us the following information. Node 2 is a synchronous replica, and node 3 is an asynchronous replica. So the picture that we see is completely similar. What about the virtual IP address?
он находится на первом узле.
175, it is on node 1.
Собственно, кластер мы создали. Ломать мы
So we have developed the cluster. We will not destroy it, and in the remaining time, we will create 2 plus 1 cluster. In this cluster, there will be 2 nodes with Postgres DBMS, and the third node will be the voting node.
Для этого мы его разберем.
For this purpose, we need to deconstruct it.
Выполним.
And to do it, well, actually there are 2 ways. Either we can say CRM cluster remove each time, or we can execute stop corusync command and eliminate excessive config files.
Наверное, пойду по второму пути.
I guess I will follow the second way.
Так, ну, здесь вот, как водится, техническая заминка. Все дело в том, что...
So here there is a technical problem. The matter is that on the first node, we had a master, and cluster arrest was to be executed consecutively starting from node 3. For example, here.
Проверим состояние, что у нас тут происходит.
So let's check the state.
По всей видимости, эта команда сработала.
Well, this command has worked.
И нам, на всякий случай, я проверю, все ли
And just in case, I would like to check whether all the tails of the former cluster have been removed. No, they haven't. But it's okay. Now I will remove them.
удалили. Здесь,
So I have removed them. And just in case, I will remove them here as well. And to be on the safe side, I will remove them here.
Если вы помните, у нас на первом узле был...
If you remember, on node 1, we had our master. And for the new cluster that we are creating now to be launched without any problems, we need to remove the locking file that we always have where the master is launched. And for this purpose, we should remove the locks that we have in the folder MP. This is PGConf log. We remove it. Now, it's okay for us to set and restart the cluster. So, we are creating 2+1 cluster.
Для этого вводим команду инициализации трехузлового кластера, но на самом деле...
For this purpose, we introduce the command of 3-node cluster initializing. Actually, we'll have 3 nodes anyway, but 2 of them will have database. That's why the initial command will not be different irrespective of the cluster you create. So we're creating a cluster made of 3 nodes.
Генерируются ключи SSH, конфигурируется casync.
The keys are generated. Casync and corosync are configured. So corosync.com file is being generated. Now, it will require us to provide passwords for node 2. After that, it will ask us about a password for node 3.
Все прошло хорошо. Здесь мы запустим
So it's all right.
наглядности монитор Красинка.
Now we will launch CoreSync monitor for the purposes of demonstration,
Кластера 2+1. Как
and
в первом случае
we
мы
will start
меняем
2+1 cluster creation.
параметры по умолчанию.
Just in the previous case, we change some parameters by default. I will introduce them first to do as much as possible today. After that, I change the cluster symmetricity,
виртуального IP-адреса.
and I config the resource of virtual IP address.
Все хорошо.
So it's all right.
Далее мы конфигурируем ресурс Postgres для двухузлового
After
кластера.
that, we config Postgres resource for 2-node cluster. It will be a bit different,
У нас появится только лишь
because
два
in the node list,
узлы, на которые
we will have only 2 nodes.
первый и второй.
These are the nodes where Postgres will be launched, 1 and 2,
Вводим
and there are no other differences.
для двухузлового кластера мы говорим, что
After 2-node
мы
cluster,
говорим, что ресурс PGSQL имеет
we can say that PGSQL resource
master-slave и говорим, что
has master-slave type.
на двух узлах. Может запускаться
It
на
is launched on 2 nodes.
Дальше мы должны сказать, что ресурс, вот этот наш ресурс Postgres,
After that, we should specify that Postgres resource actually should prohibit it to launch on node 3. There is a command with allocation parameter. It states that this resource is not launched on node 3 minus infinity.
Мы повторяем группировку
After that, we repeat the grouping of VIP master resource and Postgres resource. They should start together on one node.
Также указываем обязательно порядок.
And we should also specify the order of start.
Сначала у нас промоутится ресурс
At
Postgres,
first,
и далее у нас
Postgres resource is promoted, and after that, in case of successful promote, we have VIP master resource.
Ну и остался нам фенсинг. Фенсинг мы тоже сейчас настроим.
And fencing is left. We will set it as well in a timely manner.
Фенсинг необходим
And
для
here there is one important aspect. Fencing is needed to exclude peace-brain situations. So it is not reasonable to launch fencing and fence a node
на котором не находится ресурс Postgres. То есть
where there is no Postgres resource. So at first, we specified that Postgres would be launched on node 1 and node 2,
он у нас не запускается. Поэтому
and
фенсинг
it is not launched on node 3. That's why fencing for node 3 is not reasonable. It should not be launched.
создаем ресурс для
So we create resource for node 1.
говорим, что этот ресурс не должен
We state
запускаться на самом
that this resource
первом
should not be launched on the node itself, on the first node.
фенсинг
After that,
второго узла.
we create a fencing resource for node 2,
Что, и запрещаем запускаться этому
And
ресурсу.
we prohibit this resource to be launched on node 2.
Так, и на этом на этом фенсинг закончен. Поэтому дальше мы...
So, fencing is over. What do we do next?
Включаем обратно механизм Stonev и включаем...
We switch on Stonev mechanism and we transfer the cluster in symmetric clustering mode. So everything was stopped here, and after command symmetric cluster is equal true, everything should be launched.
Так, обратите внимание, да, вот два ресурса, вернее, два
Please
узла.
note that two nodes, number 1 and number 2,
Ну, этот наш Postgres запущен. Третий узел
have Postgres launched.
ресурс не запущен.
Node 3. Here the resource has not been launched. However, fencing resources can be launched on any other nodes, including node 3. For example, fencing resource for node 2 was launched on node 3, and this is a voting node. So now let's wait a bit, and the cluster will be launched now.
У нас осталось немного времени, поэтому
We have some time left,
хотел еще в конце
so
немножко
in the end,
рассказать
I would
про
also like
дополнительные
to
команды, которые
speak a bit about additional commands
CRM-команды.
that you can need. These are CRM commands.
Кластер, извиняюсь, прочухивается. Мы сейчас...
So we have to wait for the cluster here. And now, in the meanwhile, I would like to show you the commands that we will need
работы с нашим кластером. Или
when we work with our cluster. All the commands that we may need.
CRM Resource Cleanup.
CRM Resource Cleanup command. This command is similar to PCS utility. Here we specify, well, cleanup. This is about cleaning up the metrics after a failure when we fixed a node and introduced it into the cluster. This is the name of the resource that we want to clean. And in the meanwhile, here we have the cluster launched. The first node in master mode has been launched as well. So virtual IP address was launched on node 1, and the second node is in the mode of synchronous replica. Speaking about useful commands, I would like to tell you the following. So what is interesting here? In the beginning of our talk, I mentioned that cluster configuration can be changed on the fly. Now I will demonstrate it. For this purpose, I introduce CRM configure edit command, and here you can see a text file. You can change it on the fly. I guess that everyone can work with VI editor. Here I specified that monitor is equal to 30. I save it. So let's check whether this command has been applied or not.
Я менял тайм-аут монитора, операции монитора. Я установил ее в значении 30.
I changed the timeout of monitor operation. I specified it as 30. And it has an advantage. If you want to change the resource, if you want to change something in the cluster with PCS, you can change it for a specific resource. And speaking about CRM, here you can change everything you want for the whole cluster, and I think that this is a real advantage. What else is interesting here? What else has impressed me so much that I fell in love with CRM utility? For example, you have a cluster set and you can choose any node for executing commands on all three nodes at the same time. For example, I would like to see what is present in log folder in PG data on all three nodes. So here is the command being executed, and you can get the result from three nodes. I think that this is very convenient. You do not have to jump here or there on every node, and that is true for any command.
For example, you can say, like this. My imagination is not very good, but I write uptime. So you can check uptime on all the nodes and logs as well. Not only Postgres logs, because everything is performed on behalf of the super user. You can see the logs of clusters and message logs, etc. What else do I need to say? I think that's all. But I would like to highlight one thing. Some information about troubleshooting, about issues that may arise as you work with a cluster and software. If you have fencing, and you should have it, from time to time you may have errors saying that fencing or fencing resource stops working. They were started and they somehow moved to the stop mode. With high degree of probability, it all boils out to timeouts. Just increase timeouts a little bit, extend the timeouts, and select each timeout for a specific case. Another issue. After you have a disruption on the replica, your node is turned off. For instance, you performed some actions with the node, then some time passed, then you want to activate this replica and it cannot connect to the master because logs have errors saying that val segment has been deleted. These are standard errors. What do you need to do? You need to set up archiving. Turn on archiving in PostgreSQL. Write archive command. For example, PG backup. I use AdSync or SCP. Also, you need to edit the cluster, and as you create the resource, please add an additional parameter. I didn't mention it today, but there is this additional parameter. So to indicate the command that would take the missing vals from the archive. In my presentation, I used the following resources. These are the useful links. So I used the resources from Cluster Labs, although it doesn't contain much information on CRM. There is another document, Debian HA clusters from scratch. Also very little information there. As I said, there is scarce information on CRM application. And certainly I used repositories. I liked OK repository because CRM versions are older than the ones contained in OpenSUSE. Just keep that in mind. Thank you for your attention. I will be happy to take your questions now. Well, let me thank Igor for a very interesting presentation and ask questions from the chat. But before that, let me remind you that you can use chat in the future for other questions. Question 1. is it possible to make a text form of the settings? Yes, you can download all the settings, save in the XML file, and then say that push this file to the cluster, push this file back into the cluster. The next question. User sessions, when your user masters are turned off, can they be redirected to replica? Will they stay there? Yes, it's a known case, and we have processed it. Yes, it is possible to do this. You just enter additional virtual IP address, which, how to say this better, we use additional rules. You create those additional rules, and C-Sync allows to do this. And you say that this virtual IP address should be raised on replica, and this replica can be both synchronous and asynchronous. Therefore, if you say to your client application, all read-only address should be directed to this IP address, they will all land in replica, no matter what happens. One more question. C-Sync works on Linux, or is it specific in any fashion? C-Sync, is this the question? This service is well known and quite old. It doesn't work on CentOS only. It's a separate packet that you install. The only nuance is that in some cases it works out of the box. You just installs it and it launches and it takes off. And in some cases you have some difficulty, and sometimes I need to create SMD units that made it work properly. So, to answer your question, yes, it is available everywhere. Just deliver this packet. One more question. Which fencing to choose? So, are we selecting it at the level of operating iOS? If you don't have fencing, but you want to have it, and this is the right intention, you can use Watchdog solution. Watchdog, you can use it the hardware version. If there is a hypervisor that can emulate hardware Watchdog for the virtual machine, this would be absolutely great. If you don't have hypervisor, we can emulate hardware Watchdog of the virtual machine. You can use the software Watchdog. Of course, not all so straightforward, transparent and clear how it will work, but Watchdog will have to be set up in a certain fashion for it to verify the availability of network connection. If there are no network connections, if they disappear, the master should send for reload immediately. So it's an analog of fencing in the form of Watchdog. Which utility to use? CRM SH or others? PCS is always begins working very well from scratch. If you are new to the clusters, you can take and start with PCS, because the documentation is plenty. There are a lot of articles. Habr has a lot of information. With CRM, things are more difficult. The information is minimal. You may keep stumbling over some interesting things, unexpected things. And in this case, you'll need a mentor who would explain things to you. But if you decide to learn CRM, I would recommend that you research it and use it, because it is more powerful. More questions. Can we use Pacemaker for logs? In the cloud. Pacemaker in the cloud. Pacemaker in the way it is, in this toolkit that it has. Let me show you something. This is a kit made of 3 resources: Postgres resource, fencing resource. So if you want just take it and put it in the cloud, it won't work. You need some workarounds, some tricks. VIP master may be replaced with DNS update function and use not IP address but the update of DNS zone. And a request from replica to master will be by name and not by IP address. Client application to master will be by name, but for that you need availability of DNS, and this DNS needs to understand the command DNS update. Postgres resource remains, while fencing agent, with fencing agent, you may have some difficulties. I spoke about what to replace fencing with. Watchdog, why not? If in case of network isolation, Watchdog will simply reload the machine, and it's a good solution to avoid feed brain situation. This would be my answer. One more. How does the pacemaker choose the node to assign it as a master? Well, let's consider 2 cases. One case when you just set up the cluster, performed initialization of the database, copied with backup or your database, and launched the cluster. So it is at the 0 condition, at the original or initial condition. It is very possible that the pacemaker will select randomly, but it may select the node which is number 1 on the list. So when we list the resources, it will select node 1. But if you indicate node 2, it will select node 2. Another case is when the cluster has been launched, you stopped it, you had some disruption, it switched over. So you have some status where you have the former master that was stopped, you have synchronous replica. So in this case, the PGSQL resource has functions that it performs. It makes queries to the database and calculates, and the senior LSN will be assigned that the logic will work in favor of the senior LSN, and this node will be assigned as the master. This would be my answer. Well, let me thank you for this interesting contribution. I thank participants for their questions. Also, you can move to the spatial chat, and the button is at the bottom of the screen, so you can move to the spatial chat and then interact with the presenter. So we will resume in 30 minutes. Thank you.
Это самая удивительная способность человека — стремление создавать. Мы создаем невероятное, создаем новые возможности и верим в успех. Ведь благодаря искусственному интеллекту, облачным технологиям и 5G от Intel осуществимы даже самые смелые мечты. Мы создаем то, что вчера не могли и представить. А сколько еще впереди?
So what are we gonna do about it?
Давайте создавать то, о чем мечтают люди. Реально ли это? Реально, если мы вместе. Ведь нужна лишь идея и технологии Intel, чтобы создавать удивительное.
Hello. Today Simon Riggs visited our conference. He was the guest of first Russian PGConf 6 years ago. We remember Simon's visit and his talk. And now Simon is going to tell us about relation between Postgres and SQL standards. So it's an interesting area, and Simon is working in this area for several years. So Simon, please welcome.
As Ivan said, I'm going to be talking about the role and importance of the SQL standard, specifically to the PostgreSQL project. So why is this important? Well, PostgreSQL is the world's most advanced open source database, but really it's becoming the world's most advanced database. Now that is a very important position. It's a very important statement to realize that we are leading the way. But obviously, when you become a leader, you need to think about the world differently, and you need to think about exactly how you will lead in all fields, not just in a few. So PostgreSQL has had very good adherence to the SQL standard over the years, and there are many new changes proposed even now within Postgres 14. But many people don't know anything at all about the SQL standard. So what I wanted to do was give an overview of what that is, how it works, and again, why is that important for PostgreSQL and its users. So the SQL standard is something that's published by an organization that's run out of Switzerland called the International Standards Organization, or ISO. And it's also jointly published with something called the International Electrotechnical Commission, or IEC. And that's why the SQL standard is referred to as ISO/IEC 9075. So all of the international standards have got a specific number, and SQL is important enough in the world that the language has its own number. Now that's quite impressive of itself. It means that of all the standards in the world, SQL is in the top 10,000 standards, covering absolutely everything. And that really just demonstrates right there the central role that databases have within the modern world. And it's a responsibility that we need to take seriously. So the SQL standard was originally published in 1992. Obviously the SQL language was invented in the 1970s, but it wasn't fully standardized until 1992. Following that, it's been updated every few years with changes and additions that have allowed us to keep track of modern developments. So each new publication of the SQL standard overrides or supersedes the previous ones. So if somebody says that they're compliant with SQL 92, well, that's dead. That doesn't exist anymore. Okay, so the only thing that matters is the latest version of the standard. I mean, obviously it's useful that it's compliant with SQL 92, but the most important thing is the latest version of the standard. Now, some of the things that happen with the standard do change, but usually most of the new detail in the standard are additions rather than changes. So the latest version of the SQL standard is just being voted on now in 2021, and the committee that is looking at that is quite a long name, and I won't bother to read out the number, but it's the Data Management and Interchange Committee. Now, what some people think is that the SQL standard is published by a group of people that believe that SQL is the only possible way of doing things. Well, actually, that's not true. The SQL standard is published by the data management and interchange group. Now, they could have voted any standard at all, and they do consider other languages and other approaches. So they're not completely bought in or wedded or linked to the SQL language. It's just something that they have previously published. But this same body was also responsible for standardizing network databases with the codicil standard that emerged more than 40 years ago now. So the standard does have a very wide remit. It doesn't just think about relational databases, it thinks about data management in general. Now, the standards process is quite complex, and the standards groups from different countries are all separate. So you may have heard of something called the ANSI committee. Well, actually, that's the name of the American National Standards Institute. And obviously, many of the people at this conference, including myself, would not be allowed to partake in the US committee. And that has actually been something of a problem for PostgreSQL, because we're not all based in America, we're based all over the world. So if you've got the ability to influence your own national standards group, then please do so. But it's very difficult for us to work together on that, because obviously, you know, I can't attend the Russian one, you wouldn't be allowed to attend the American one, and you know, there's lots of different groups in different countries, Germany, etc. So it's quite fragmented and quite difficult to contribute to. But anyway, we are trying to contribute, and that's the most important thing. So the standard itself is actually an extremely long set of documents. It's broken down into a number of significantly large chapters. The foundation, which is chapter 2, is probably the longest and runs to hundreds and hundreds of pages. But each of the other topics have their own manual on it as well. So taken together, it's thousands of pages of standardization documents. Now, what makes it harder to conform to is that we're not allowed to publish the standard itself publicly, but you are allowed to purchase a copy of the standard document and then use that information to build standards compliant software. So that makes it just a little bit harder, but the standard documents aren't that expensive, so it is okay to continue. Now, I've highlighted in this list a number of places where we've already done very good work in PostgreSQL to implement the full standard. So the SQL Foundation is mostly achieved. We've also done a lot of work in the management of external data, specifically around foreign data wrappers. And the SQL schemata is something that's already in Postgres, known as the information schema, and that you'll see on many other databases such as MySQL or SQL Server. We've also done some initial work on the XML related specifications, and you'll see in the latest versions something called the SQL property graph queries, or SQL PGQ. Now, what's interesting about that is for the really for the first time, the SQL standard is moving quite heavily towards supporting graph queries directly from SQL. Now, as I'll point out later, we do already support a lot of graph type queries within the standard, but this is an attempt to move even closer to graph query languages. So what I'd like to do now is I'd like to take you through an overview of a number of different features that have emerged in Postgres or emerged in the SQL standard, and what level of support we have for that within Postgres. So Postgres 6.1 in 1997 had sequences. This was a concept introduced by Oracle, but didn't become accepted by the SQL Standard Committee until 2003. So in that particular case, you'll see that Postgres was 6 years ahead of the standard in introducing things. So where that is true, I've marked that in blue. Again, Postgres 6.5 in 1999 introduced something called the limit clause, which obviously restricts the number of rows returned from a query. A very useful facility. And again, you'll see that the SQL standard didn't implement that concept until 2008. So in that case, we were 9 years ahead of the standard. And again, with truncate, we were 8 years ahead of the standard. So you can see that PostgreSQL has already had influence on the SQL standard, in that things that have been widely adopted because Postgres adopted them have led people to understand that they needed to improve the SQL standard to match the reality of databases being used by people. Now, the other way round is also interesting, because in light red or pink, I've marked a number of features which were pioneered in the SQL standard and then later put into Postgres. So, for example, window functions emerged first in SQL 2003 standard and were enhanced in the 2011 standard, but we didn't implement those into Postgres until 2009. So that's 6 years behind the standard. Now, I think that what I'd like to say about that is that Postgres at the time had much more important priorities to work on than some fancy window functions, but we did consider it important to implement them in the long run. So while I've said that we were 6 years behind, that's not a criticism of the project or anything along those lines. Just what I meant to say is that the SQL standard was just simply ahead of us. Now, there's a number of other features that we can go through where you can see that the standard was introduced substantially before Postgres implemented it. Now, while we like to say that Postgres was invented in the 90s, and it was, there wasn't much work on it happening in the 90s. It's only really until the 2000s and very much in the 2010s that a lot of work has gone into Postgres. So I think that you can see the reasons why we were slightly behind on those implementations. Again, there's a couple of things that we can talk about here with the merge command. So there's a patch into Postgres 14 to implement merge, and also for system temporal tables. And as yet, we still haven't committed those. And I'll talk a little bit about that later. But one area that is quite difficult for us is procedural languages and JSON support, because in both of those cases, PostgreSQL was significantly ahead of the standard in implementing features into the database. And what's happened with those two specific features is that the Postgres syntax and approach is quite significantly different from that required by the SQL standard. So in order to catch up in both those areas, we would need to do quite a lot of work. And it's, it's doubtful as to whether we ever will, but I guess, that's just time. All we need is time to catch that up. Now, the JSON features are not fully published yet, and we're expecting the JSON feature set to be published in SQL 2021, possibly 2022. We'll see how that goes. It's difficult to predict exactly when the implementation will succeed. But we do already have quite a lot of work underway to implement the JSON features as well. So what I'd like to do now is take you through some of the details of these advanced features, show you some of the syntax and explain why those features are important for Postgres. So my first stop is with window functions. Now, window functions allow you to treat the data in relational tables as if it was ordered. And you can see select average is a standard aggregate function, but when we include the over clause and the order by log timestamp, you can see that we're actually considering the data in an ordered manner rather than normal relational, which is to assume that the data is unordered. So the window function is very interesting when you are trying to compute things like moving averages, where you want to consider data that's most recent to be of greater importance than older data. Now, normally you'd see something like range between 3 rows preceding and current row. But what's quite interesting about this syntax is that the SQL standard allows for, and Postgres supports, the concept of a time-based window. So here you can see we're saying include all of the data within the last 3 hours. Now that's an interesting concept because we're not considering rows here. We don't know when we write this query whether it's 300 rows or 3 rows or even 0 rows. It doesn't matter. So what all the query is asking is to analyze the last 3 hours worth of data. And I think that's a very powerful concept that has been introduced there. And that brings PostgreSQL's support for that into a very important area, because what this does is it recognizes the role and importance of time series data. And Postgres does have significant support for time series data. Now, one of the themes that I will go into in this presentation is to highlight to people that PostgreSQL does have support for other types of data other than relational data. And that's something that people quite often throw at Postgres and say, you don't do this, you don't do that, you're just an old relational system. Well, Postgres did start a long time ago, but SQL has evolved, so has PostgreSQL evolved. And as a result, we're able to cope with much more advanced data types and advanced styles of processing in our database queries. So I see this as quite an important piece of functionality for users. Another related piece of functionality is recursive queries. Now, if you use the with statement on its own, that's something like a macro in that it allows you to encapsulate a complex piece of code and use that repeatedly. But when you say this word recursive, with recursive, that completely changes the meaning of this query. So what we have here is the text above the union all, select star, comma, array. That part of the query is the starting condition for a recursive search, or otherwise known as a graph query. So you specify the starting condition or the starting set of rows, and then the second part of the query is what's known as the recursive term. And what that does is iteratively work from the starting condition through to another set of rows, and then another set of rows, and the query will keep going until it stops generating rows. Now, obviously, one of the problems with this type of query is that if you write it incorrectly, it could be an infinite recursion, which is not very useful. So sometimes it's quite useful to use a statement timeout when we're using recursive queries. But the power of this is that it is a full graph query. So when people say PostgreSQL is a relational database and it can't do graph queries, they're completely wrong. And you need to tell people they're wrong. PostgreSQL can really do a hell of a lot. And the more we let people know about this, then the better people will think of PostgreSQL. So you're probably thinking, well, okay, so you can do a couple of graph queries, but surely you can't do all graph queries. Well, that's an interesting point, because the Sparkle language that was designed specifically for graph and link traversal has been shown to be exactly mapped onto SQL. So there are no Sparkle queries that don't have an equivalent SQL form for them. And there's also a benchmark been produced for graph data called the well, it's actually produced by the Linked Database Council, or LDBC. Now, the LDBC benchmark has been written fully and completely in SQL for Postgres. And so every single query in that benchmark can be expressed using SQL. Now, I think that's quite an impressive statement, because it's showing that many of your graph query needs can be expressed by PostgreSQL. Now, you might then say, well, you know, why would you use a graph database? Well, I think that's really a good discussion to have with the graph vendors. But you know, I think in terms of online transaction processing, where we're doing short queries and retrieving small sets of data, then Postgres is definitely just as fast as other systems. So where are we taking this now then? Where's Postgres going next? Well, when we initially committed recursive queries back in 2009, the commit message did say, we don't support search and cycle clauses yet. And it's taken us, unfortunately, 10 years to come back with this new syntax. But the search and the cycle clauses have now been committed to Postgres 14 by Peter Eisentraut a couple of weeks ago, or a few days ago at least. So that is a very important change. Now, the cycle clause allows you to write the query in an easier way to avoid generating loops in your graph queries. And the search clause allows you to specify whether you're going to have breadth first or depth first searches of the graph, which is again a very useful property. So those two additions are quite important. Those are definitely already in Postgres 14. But on top of that, we are already beginning to work on this new part of the standard, which I'd referred to before, called SQL PGQ, which is the property graph query. And we're expecting that to become part of the SQL standard in either 21 or 22. And we then expect that to go very quickly into PostgreSQL. So in the past, where we had maybe a 6 or 8 year wait for standards work to appear in Postgres, we're now seeing that we will be able to put that work almost immediately straight into Postgres to allow users to take advantage of the new standard syntax. So moving on, I can introduce you to the merge statement. Previously, SQL had the fairly simple commands update, delete, and insert. Well, what the merge command allows you to do is it allows you to merge data from a sort of bulk data source. And what it does is it joins the source data with the target data, and if there's a match between the two, then you can execute the when matched clause. And for example, you can say when matched, then do an update, or when matched, then do a delete. If there is no match between the source and the target, which means the same thing as the row is not already in the database, then we can say when not matched, insert values. So what this gives us is a command that's very similar to a load utility, all in a single command. And that means the merge statement can be used both for bulk data processing in large or data analytics systems, but also in OLTP systems, where you can specify quite complex operations without needing to go backwards and forwards to the application. So it allows you to encapsulate complex logic in one place, but it also allows you to avoid network traffic by needing to write procedural language code in order to handle that complex logic. So it's quite an impressive utility, and obviously other databases, some of them do have it, but it is a very important utility for application programmers. Now, rather regrettably, the standard does not define the concurrent behavior that the statement should use. And obviously that has then led to debate within the PostgreSQL community about exactly what the concurrent behavior should be. And while it might not be immediately obvious, the discussion over concurrent behavior changes how we implement that internally. And obviously it's been difficult to understand exactly what shape of internal changes are required for the executor. But there is a patch, and I'm very hopeful that while it might not go into Postgres 14, I'm very hopeful that it will make its way into Postgres 15 earlier in the new development cycle. So again, a very important utility, and we're quite thankful to the SQL standard for specifying it, because without that, it would be difficult to invent such a complex utility without becoming massively non-standard, which is not really of benefit at all to anybody. There's another feature that is in the SQL standard called system versioning, and this is something that's quite similar in concept to MVCC. The idea is that the database table would keep track of all of the old versions of rows. So when you update a row, it doesn't disappear, the old row doesn't disappear from the table. What happens is you simply mark the old row as no longer valid, and then you insert a new row. So this then allows you to write what's called temporal queries, where we actually specify a timestamp that gives us a viewpoint of the database at that particular point. That's a very powerful capability that many users have asked for over the years. This is actually one of the most frequently requested features at least to me, over the years. So the SQL standard does support some logic for this, and we are endeavoring to support that, but we're not really sure about the current patch that's in Postgres 14. Another feature is some better syntactical support for SQL standard procedural languages. There's the ability to use the return clause directly within a function. So if you've got an SQL function called squared, you would simply return the input times the input rather than slightly longer ways of doing things. Now, again, is this a new capability or is it just syntax? Well, in this case, it is just new syntax. It doesn't really give us much addition. But again, this is where we need to consider the effect and importance of PostgreSQL. Because we are becoming the de facto database worldwide, it's very important that we're respectful of standards. It's very important for people's careers that they can take things that they learnt in other databases and bring those things with them when they move their careers to Postgres. So the SQL standard is a very important way for people to more easily adopt Postgres when moving from other systems. And again, you can see the create procedure syntax uses something called begin atomic, indicating that all of those actions would be within one transaction. Again, it's not adding a lot of value in terms of functionality, but it is adding a lot of value in terms of convenience for people adopting the new system and moving code between systems. Now, PostgreSQL needs to take the best attitude towards that. We're an open source database system, and it means that we need to think much more about openness than maybe other projects or other commercial systems might do. The next thing to talk about is JSON support within the database. And I know many people attending this conference today have spent a lot of time working on JSON support, both in terms of functional support, but also in terms of data types, optimization, and of course indexing for support for supporting JSON. Now, what we have in PostgreSQL at the moment is quite similar in some ways to the standard. You'll see that the code above the line is very similar to the code below the line, so it's not that hard for us to support that new syntax. But what I would observe is that there's a lot of changes to make in order to get us to support that, and that has meant some quite lengthy patches, and I would here big kudos to Nikita Glukov for having the patience to produce more than 50 versions of a patch implementing some of these changes into PostgreSQL. Very frustrating to go through that many reviews. But I think we have an approach now where we're going to break that down into pieces and then accept the pieces one by one, which makes it a lot easier to understand and commit. So good luck with that one in the current commit fest. So just in summary then of all of the different SQL standards patches that we have in Postgres 14, you will see that there's quite a lot of people involved from multiple companies, obviously EDB, but Postgres Pro and other people from other companies reviewing things. What you'll see is that there's a genuine attempt across the whole standard to implement exact compliance with the standard. As I say, that has been successful in at least one patch already with the search and cycle clauses, and there's a few more, but you know, I don't think all of the patches will make it into Postgres 14. That doesn't matter, but I think what does matter is that we continue to push forwards in as many areas as we can to increase the level of compliance with the SQL standard. It's important for us to be compliant with other databases, but it's also important to be respectful of the people that are generating these new standards, who are trying to set a direction for the industry, and they would like us to follow that direction. And here you can see that we are doing quite a lot to move things forwards. Now, in some cases, some of these patches are just syntax, and you might say, what does that matter? But it really does matter, especially where we have new features involved, such as the merge or system versioning tables. But the syntax itself does matter because it helps people to migrate to Postgres, both their careers and their code. So the vision that I have for PostgreSQL, and one that I hope that you will follow as well, is that PostgreSQL should actively follow all of the different standards, whether those be SQL, IEEE, OGC, IETF, Unicode. And if we follow all of those standards, then we will have an amazing product, because it will be very easy to use, it will be fully standards compliant, and the features that we implement into the database will make sense. I think it's easy to sit and think that you would come up with a better design for how things should work than the people in these standards committees, but actually the standards committees are full of people that are bringing their lifetimes of experience to us, and we've really got to take advantage of this. We can't think of everything ourselves, and this is really where Postgres becomes much more of a citizen of the world. Instead of just pretending that we can work within our own box and work on our wonderful database, because it is wonderful, but we really need to reach out to other groups around the world, different types of standard, whether that be standards for geographical information systems or security standards. It doesn't really matter where the standard comes from. What matters is that we should be following it, because we need to take our place as leaders in the database community, not just followers. And that's where I think our destiny lies now. So I see that we will have more standards compliance in 14, and things that don't make it into 14 will make it into 15. And you will also see the many new parts of the SQL standard arriving in Postgres 15 and beyond. And what this gives us is it gives us a database that I had previously called hyper-converged, meaning that there's multiple types of data all integrated into one robust and secure database with lots of different specialized data types, and not just data types, but the functionality to truly take advantage of each of these types of data. So I know Oleg and his team have had huge input into the full text processing and JSON and XML. but there are other areas as well that are particularly important. If we can bring all of these types of data and styles of processing together into one database system, then it will be a world-leading database system. And that's where I think we should go to. And I'm sure you're already contributing to this vision, but it's a vision that we need to explain to other people where we're going, why we're doing it, and where we get some of our ideas from. We get our ideas from users and we follow standards in order to implement useful solutions across a whole range of different data types and styles of processing. So, thank you very much for listening to me. It's possible I might be able to answer your questions, but obviously the whole range of topics I've talked about today might easily be answered by some of the other experts here as well. But if you do have any questions, I would be very happy to take them. But thank you very much for listening to my words today, and I wish you a good conference. So thank you very much.
Simon, it's really an interesting and a very rich topic. So please answer the following question. Postgres is famous with its rich system of data types, and its extensibility is strongly based on this system of data types. It is much wider and much richer in functionality than is possible probably to have in SQL standards. Do you know, will Postgres, will it be easy to stay compatible with the standards because of the way how Postgres is extended is very strongly linked with its internal design, with the data types and so on?
Well, I think that's a good question, because there are two purposes for the extensibility and the standardization, and in many cases they're orthogonal to each other. The standardization gives us a firm base on which to build our applications, but the extensibility allows us to implement advanced new features within the database. And so the standards process is sort of coming from behind, and the extensibility is reaching forwards, so that they have a different role within the database. Now, it's a good question, because it's likely that we will develop extensions that are then later incompatible with the standards. Well, that's just a problem that we have to manage. But the role of standardization is to bring everybody in the world up to a common set of standards on an accepted subset of functionality. So the standards don't need to apply to everything. They just need to apply to the things that everybody's using. So new features, new functionality can always be part of extensions. So they go well together.
Okay, thank you. For example, let's take a look at JSON, which in Postgres is implemented by already two different data types, JSON and JSONB. So what is your opinion? How will it be, how should it be made compatible with SQL standard, where nothing is said about special data type for JSON?
Yeah, I mean, I think it's quite a difficulty, but it is an area of rapid development by multiple vendors, and that's exactly why it's not standardized yet, because the standardization process could easily freeze something too early. So once the industry has come to a kind of agreement as to how things should work, then they can be standardized. So we mustn't expect the standard to lead the way so much. We really expect the standard to go behind us. So we must lead the way, and then implement the standard later.
Yes,
So
and
I
this
think,
is probably Postgres is doing now. It's leading the
yes,
standard in JSON.
yeah.
By the way, do you think that JSON path is somehow following the JS query extension of Postgres? Or maybe inspired by it?
Well, yes, I think so. I mean, it seems to have been close enough for us to use, to implement relatively quickly. I was very impressed that we managed to achieve that within one release cycle. I mean, a lot of patches bounce around for years before they're accepted, and so you did very well to get that accepted. I mean, who can say where the ideas come from standardization, but I'm glad that it's been standardized, and I'm also glad that we are compatible with that now. So I know that there's some difficulties in that area, but there will continue to be. We can't always expect that the standard will exactly follow what we have done. But it's standardization is always a discussion and meeting in the middle process. So we can't always expect to win that.
Okay, Bruce. Sorry, Simon. Another question. What about full text search? Do you think it is going to be standardized in some way?
Well, probably not, but I mean, it should be. I think what we need to do in the future, and one of the reasons for this talk, is to encourage people to get involved with the standardization processes. And if we understand that we are the leaders here, and that the world is actually waiting for us to say what we are doing and what parts should be standardized. So yes, it would be very good to see that type of contribution. Now, of course, it takes a lot of time and effort to do this type of thing. So I'm not expecting everybody to just stop doing their business and go and work on standards. It doesn't happen that way. But as the Postgres ecosystem gets bigger, it becomes easier to fund people whose job it is to pursue the standardization effort. And that then benefits us all, because then we're leading the way in terms of solutions, but also leading the way in terms of standardization. So.
Yes, for Postgres, of course, it is much more difficult to be a leader in standardization, because probably large companies such as Microsoft and Oracle, they have more resources to put into this process. And so it is much more difficult to compete with them in this area, in standardization.
Well, I mean, I guess we haven't found it that hard to compete with them so far, have we? We've been doing very well, and this year open source databases came out on top over commercial databases. So what we have to realize is that we are winning, we are leaders in the space, and that we need to step up to that responsibility.
Yeah. Okay, thank you, Simon. Very interesting talk and very interesting answers for the questions. So I congratulate you and everybody. So we are leading, we are winning. It's great.
Good. Thank you.
So once more, thank you. There is some special chat on the conference platform where you can go there and talk with people there. It's an interesting place where you can move around in some virtual room and listen to the people who are close to you. So for everybody, including speakers and attendees of the conference, we have lightning talks. Please submit your proposals for lightning talks. It can be done on the conference platform. Don't forget with this, and don't forget to rate the talks and put your star for Simon's talk, which was very interesting. Once more, thank you, Simon. And now we have a little break, and in 10 minutes we will return for another talk.
Это самая удивительная способность человека — стремление создавать. Мы создаем невероятное, создаем новые возможности и верим в успех. Ведь благодаря искусственному интеллекту, облачным технологиям и 5G от Intel осуществимы даже самые смелые мечты. Мы создаем то, что вчера не могли и представить. А сколько еще впереди?
So what are we gonna do about it?
Давайте создавать то, о чем мечтают люди. Реально ли это? Реально, если мы вместе. Ведь нужна лишь идея и технологии Intel, чтобы создавать удивительное.
Здравствуйте, еще раз.
Hello once again. Here we have Dorofei Prodeskovsky. He is a developer of PostGIS. I guess that he is one of, probably you would like to substitute your centroids by this function. Another thing that we have now is overlay engine. Now the functions of union, intersection, difference, sim difference use a different engine. In theory, it was to give similar results, but actually the results are a bit better. In the past, when between two fractures in floating by, it was not possible to find a common point or calculate overlapping correctly. Now, this engine, if it did not manage to calculate something in fractures, will be switched into a new mode and conduct computations in it. It means that you can sacrifice last millimeters of your values, but you can get an adequate answer that will be quite accurate. It's very useful if you have some computations and you know the accuracy. When you want to work with specific geometry, probably you would like to transmit it directly to simplify the work of your engine. Some things have become more convenient. So this thing appeared in 3.0. It is called ST tile envelope. If you prepare web maps, probably you had to ask for some base boxes depending on the number of tile that was transferred. So tile is provided by zoom of the web map. There is X and Y computation. So everyone who needed it shipped their own function of this version. Some of them used Python, others PGSQL, and since 3.0 version, this is an official part of Postgres, and it is written on C. So you can substitute all your functions by it. And also since 3.1 version, it includes a buffer argument. It allows you to enlarge the square to take the things that are right beyond the tile. Another function that has become more convenient is collection struct function. If you have a lot of invalid geometries, for example, you allow your users to draw polygons and you do not explain them, which of them are appropriate and which not, you can get quite a lot of garbage data in your base. To clean it more efficiently, quite frequently, it is necessary to clean some common lines from the polygon, some points that can be found in polygon. In the past, collection extract function was used for it, but it was necessary to specify the type of geometry that you expect to find. But now, it's not obligatory to do it. If you provided your collection of polygons, lines, and dots, it will return only polygons from it. If only lines, then it will return only lines. So, it can save a lot of efforts. Another problem that is frequently faced by newcomers is an attempt to insert into a table with a specific geometry, a geometry in a different coordinate system. Very few people notice that when you try to insert your table, when you try to insert a pointer to the table, you insert not only the text representation, but you also specify coordinate system as our ID with 0 identifier. In the past, we would have a limitation in your table stating that geometry can have only SRID 3857, then specifying this geometry without SRD wouldn't be possible. And version 3.1 has resolved this problem. It's possible to insert geometry without SRID, and if you know in what table it is inserted, this SRID will be written automatically, and it can really save a lot of efforts. because people frequently ask about it.
If you need to cut it into squares or rectangulars, it was hard to generate them in the past. Now we have desc_gate function, which can define the size of our rectangular shape and basically the shape itself. So starting from the start of the coordinates, the system will generate the squares that will have interesting features. Those squares will be the same for all other geometries you'll have to generate for the same parameters. So if you decide to create a 400,000 meter mesh, in our case, then you submit it to Brazil and you generate it for Brazil. If you send it to some other country, it will be generated for that specific country. And you'll see the matches with the geometry. Another convenient feature, force 4D, it's a function that transforms your coordinates, 3D coordinates into 4D coordinates. It has two new parameters, new Z and new M. If Z or M does not have it in the geometry, it will be added. And also, if for some reason there are coordinates in the table and there are some coordinates, a height, for example, which is in another field, or you have some array that you would like to use in the same spatial algorithms, then you can assemble such a 4D point by applying force 4D in two new points. Then you get 4D points. Why would you need this? First of all, before making a 4D, first need to understand why do you need 3D. We live in a 3D world, and in this 3D world we have latitude, longitude, and height. This is the system of coordinates, is used only if you use surfaces or planes. But if you deal with earthquakes or other natural phenomena that take place underground, for example, or you don't like the 180 meridian, maybe it is too far away from you, then you might want to use other space for your spatial algorithms, X, Y, Z, and in the center, located in the center of the Earth. This is a 3D globe, a 3D system of coordinates without any transformations. There are no issues with meridians because they are non-existent any longer. It is ideal for analysis. It is used in GPS as it is. One drawback only. It is not possible to show it on a flat display. You need to make cuts and software doesn't know how to do this, and now 3D monitors are able to show this. Why do you need this? It is needed to perform analysis. In this case, for example, we clustered the full planet Earth into small regions with the new function k-means. Northern regions become really big in size, but this is only a seeming impression because all of them are pretty much the same in size, but they're big because they're in the north, and Mercator projection kind of stretches. When you do it in real 3D, this issue becomes non-existent. You don't really see this. It doesn't manifest itself. And this is the population data. Also, you can see that here we use mass. For mass, we use the GDP of each region. Moscow cluster, it has become the center. And in London has become the center. And some other things happened which we were not able to achieve in the cluster analysis. Now it is possible to do in Postgres. This is the map of economic migration. People move to places where they can make more money. Or you can perform some other type of analysis of your own. Another feature, I spoke about squares that can be generated, but if you want to join them, it's better to do it with full outer join. It would be good to overlap them. Before version 3.0, it was not possible to do this because Postgres didn't know how to full outer join. It could do some things for under specific conditions of index class. So we finished and completed those tweaks. Now you can do join according to different geometries, full outer join inclusive. We're looking forward to Postgres being able to do full outer join for all other tasks. For convenience, we also suggest JSON updates. Unfortunately, the sound is not very good. You can provide a full row in STAS.GeoJSON. So we can get the table in full.
Улучшена работа с проекциями. Теперь нужно проставлять правильную проекцию после того, как специфицированная в JSON проекция. В спецификации прямо уже написано, что там всегда широта.
So the specification says that it contains a latitude and longitude. If for some reason you don't have standard JSON, you can still handle this.
И новость 3.1.
And news 3.1, starting from 3.1, we can now add JSON. If you want to add it into geometry field, you just assign it there and it will work. This is good and it really saves time. A few words about performance. This year we improved Hilbert sorting. Why would we need this? Hilbert curve is a curve that fills the full space, but it is a single curve, doesn't cross anything else, which goes around regions, goes next to them. What does it do to us? It helps us make a 2D map better, or sort out the 1D space in the tables. And this helps make certain optimizations. So the first thing you can think of is, let's do Brin on top of this. If we sorted something in the spatial location, then next to it, we may have tables or points in the 2D environment. We can make boxes around them, and this will look like an original Hilbert curve. Vladimir Agafonkin has a good demonstration. If you follow this link, you'll see it to that end. And until recently, it is now supported in PostGIS. Why until recently? It existed in the past, but at some point of time, Postgres had a patch which broke planning of Brin indices for all types, similar to rectangulars. And no one wants to admit that that patch broke everything up. So we had to make some support on behalf of Postgres, and now we are able to build such indices. We do that for planning, and you can actually use them. So to create an index with Brin, you need to sort your table, sort by geometry, for example. and then you'll get a sorted table like on this page, and then you create index, and those rectangulars are created, and then you'll understand which part of the table you should look at. This index takes very little time, it is small, and also it is effective, so please make good use of it. Starting Postgres 14, thank you to Andrei Borodin, we will have the same feature in GIST. It will be built with the same algorithm as Brin, which will help us build it 100 times faster. So we're looking forward to it. We are looking forward to this being in Postgres 14. Another important thing, so please double check this. Make sure you use the updated version of Postgres. Postgres
Версия 2.3, например, которая запакована в довольно много разных бытиев.
Version 3.1 is no longer supported. 2.4 will stop being supported soon. So please update to 3.1. As long as everyone remembers how to update from old versions. There might be people who do not know how to update. They say, we have version 2.0, please update it to 3.1. They don't remember how to do it. So there is documentation, but people can't remember the small things which are important. So update ASAP. So here is more information if you follow the links. In Telegram, there is chat, Postgres chat. Please refer to it. So come there, ask questions, including questions in the English language. If you are a Postgres developer, please help us with these patches. Patch number 1 is the patch of Andrei Borodin. It was committed, but we want to make sure it works and it is not uncommitted. The next thing is about broken Brin planning in Postgres. If anyone is ready to commit a one-row patch, which for some reason causes issues with the community, please, we're looking forward to your help. Copy freeze. This is a patch necessary. So when you import a lot of data, after this big amount of data, so that you don't need to walk through this data again. So, of course, you don't want to read your database twice. And this patch helps you avoid this. So it might help in your big data pipeline. That's all I have for today. These are my contacts. So your questions are welcome. The microphone is muted on our moderator's headset.
Раз.
Меня не слышно было, pardon. Я хотел сказать, Дорофей,
Let me repeat this. What I wanted to say is thank you, Dorothy. Also, please forward your questions to the chat. So while we're still waiting for the questions, I have my question. So 3.1 version, and what is expected to be done before it becomes 4.0? So, well, the new version means breaking changes. So something needs to break, and then we need to cure. So when we change the major version, we try to maintain the compatibility, the binary compatibility. So you can use binary 3.1 in your production will with simple restart without any need to redo indices or record something repeatedly. If we need to break something at some point, maybe we'll get enough issues for version 4.0.
Понятно. То есть, есть ли вообще в этом проекте какой-то такой roadmap, что там 4-й версии будет?
Does this project have a roadmap saying that version 4.0 will include this type of functionality, and in version 5.0 that type of functionality will be added. Well, yes, we do have this roadmap, we do have annual planning. When we get together, all our team gets together to discuss what is upcoming. So, because it's a community project, not all commitments are executed, but this is internal process. So that's why we don't share it at the conference. Just wait for next year when we start pushing things. But the things we're working on are visible. That's why I address Postgres community to come help us on certain issues. Clear. Another question. Well, when discussed 4D, why is mass perceived as a separate coordinate and not as a function of the remaining three? This is a philosophical question. Z and M, they have different values. Z, oftentimes, depending on whether it's a flat 3D or 2D with Z which cannot be repeated, or you may have a system of coordinates which is indeed 3D and you can make a ball out of it. So depending on this, you see different properties. Our library operates only with 2D data. That's why Z is a dependent value and it doesn't participate in the analysis in most functions. In some functions, it starts playing a role. This is why it should be added before analysis. Similar thing with M. In different situations, so historically, it is present in all systems, and it includes something. Everyone contributes something to this M. So everyone perceives M in a different fashion. Saying, for instance, here we have not just one object, but 4 similar objects. Somebody reuses such coordinates. These are informative data that can be put hand by hand in geometry. All right. I have 2 more questions. GeoJSON. Is it JSON or JSONB? This is usually a text. So oftentimes you need to give it to the client. That's why it is perceived as text or as JSON. Text not to create too many allocations for a given object. Well, you do a trivial cast and make JSONB out of it. But normally, you're not supposed to keep GeoJSON in the database, because there are other features intended for exactly this purpose. Another question. Daniel Varadza, a developer of PsychoAPG. He says PsychoAPG does not have special support of geometric types, but now he's developing version 3 of PsychoAPG. And the question is, are you interested in having more integration in PostGS and Beton? Does anyone use this couple? Yes, many use this couple. It was SQL algorithms, ORM. So the main issue with ORM is when someone wants to appeal to the objects in the database as the objects of their own native language, and the problem occurs because mapping takes place through ID, and it is deeply integrated in the DNA of traditional databases. So this is a phenomena where relational theories are executed not through AD, but through the test of spatial compliance. Dorothy, well, our time is up. So I believe Daniel is interested in cooperation, so you can move to the spatial chat to discuss this more. So again, our time is up. Once again, thank you very much for your contribution, and we're looking forward to the next report, which will be delivered by Julien, and he will frighten and scare us with all the new updates.
Друзья, следующий спикер у нас Жульен Рухо, это один из разработчиков.
Friends, our next speaker is Julien Rouhaud. He is a Postgres developer, quite famous, and now he will present his pre-recorded presentation where he will frighten us with various dangers and reveal actually that it's not that dangerous, speaking about updating libc or ICU library that can affect ordering in the base. Let's listen to him.
Today I will teach you how not to fail your next libc upgrade, or how Postgres 14 will help you avoid index corruption due to collection change. So let me introduce myself. My name is Julien Rouhaud. I'm a developer and a DBA, and I've been working on PostgreSQL since 2008, and I never wanted to change ever since. I'm contributing to PostgreSQL and its ecosystem in general, like the extension HyperPG. Collection defines various ordering that you can use to sort your data according to some language-specific rules. Postgres heavily relies on the operating system to provide the various collection that you may use. One example is glibc on GNU Linux. Since PostgreSQL 10, you can also use the collection provided by ICU. It's a very powerful library that provides configurable collections. Since collections are used to sort the data, they are obviously also used for index creation and maintenance. One very strict requirement for indexes is that the way the data is sorted should never ever change. Obviously, that's an easy requirement for numeric data, for instance. But when it comes to text data, that's another story, because the rules that states how text data should be sorted according to some specific language rules tend to change over time. And also, bugs exist, and various libraries that provide such collection also have inversions that can break this heuristic. So, what happens if the collection library start to change the way the data is sorted? The answer is simple. All indexes that rely on this specific collection can be immediately corrupted or not. That's another problem. It depends on what are the actual data you have in your tables. But if you happen to have impacted data, your indexes will be immediately corrupted. And one problem with that is it won't be a physical corruption, which will be immediately spotted with like some hard errors. It will be some kind of a logical corruption, and this can be hard to spot because the outcome of that is query will start to randomly give wrong results or different results depending on how the index is internally created, or if the index is used or not. This also became more problematic recently with 2.28 version of glibc, which broke a lot of collections that were usually very, very stable, like the English collection. There's another extra caveat that's known, and it leads to somewhat frequent reports on the community mailing list. That caveat is when you are using physical replication, and if your different servers have different OS version or just different version of the collection library. If that's the case, you will basically have like the replica, which will always be corrupted with no real way to fix that corruption, unless you fix the root issue, which is you should have the exact same collection library version of both your primary server and all the replicas. Currently, there are only two ways to detect the problem, apart obviously from noticing a query giving the wrong result. One way is to use IMCheck, which is an external extension provided in the contribs, to perform a check on your indexes. This only works for B3 indexes, and it will perform a very thorough detection of any problems that can exist in your index, not only problems due to collection changes, and it's unfortunately quite costly, so you can't really run that on a very regular basis. The other option is to carefully follow all updates on your servers, on your packages and your collection library, and check every time your library is updated to see if it can change the collection you are using. Unfortunately, none of those solutions are really practical for something that should be a systematic check. To solve this problem, Postgres will now, since PostgreSQL 14, track the collection version when an index is created or re-indexed, and it will store all the information needed in the PG-depend catalog table. So there is now a new ref version column that was added. Then, the first time an index is used in any new collection, Postgres will compare the recorded collection version with the one currently installed as your operating system will report, and it will raise the warning if they don't match. To be more precise, this will happen the first time the index definition is loaded. So even if you end up not using a specific index in your query, the simple fact of looking at the index is enough to maybe raise that warning. So that's a good thing. Here's a simple example of a warning that can be generated in such case. As you can see, it will give you all the information you need to take further action. You will have the impacted index name, the underlying collection name, and the two versions involved. You can also note that if the index has dependency on different collection, a separate warning will be generated for each of the collection impacted. But if your index has multiple dependency on the same collection, only one message will be raised. Here is an example on how to query the catalog to proactively find the same information, but even before the query, any of your query use the impacted index. It can be a useful check to run after each on your OS update if you want to be sure that you don't have any corruption. Note also that there is a new reg collection, as you can see here. A new reg collection data type which has been introduced to make this kind of query easier to write. So, one question now is what to do when upgrading to PostgreSQL 14. As the previous version didn't record the collection version, there is no way to Postgres can know whether the indexes were maybe corrupted or not, because it just didn't have this information. So, to avoid like a storm of warning being generated after a PG upgrade, which wouldn't really be helpful, by default, PGConf will assume that all your indexes were using the current collection version and thus shouldn't be corrupted. So that may or may not be the case for your own index. You have an option if you want the opposite behavior, which is assume that all indexes relying on collection are or may be corrupted. And if you want that behavior, you need to use --index -collection -versions -unknown. It's a bit verbose option. So you can use that option to PG upgrade if you want, and you will get the opposite behavior. So let's now see some limits for that approach. So it's not bulletproof, and it can raise false positive warnings. Because what this approach does is check for version change in the underlying collection library. It's not because the library was updated that it actually changed its ordering and broke your indexes. So what that means is that when you read this message, you have a decision to make, and Postgres will not make the decision for you. So one of the decisions you can make when you see such a message, or proactively using the query I showed you earlier, is to simply re-index all the impacted indexes, and this way you'll be sure that you won't have any corruption. It can be obviously a bit costly and consume some resources. So you also have the opportunity to explicitly clear this warning and tell Postgres that you know that the update didn't break your collection, and you can assume that your index is not corrupted. So I really want to stress that out. Like if you manually clear that warning, and if you're wrong for some reason, you will actually hide some corruption, which is a bad thing to do. So really only use the alternative approach only if you're really sure, and if you have any doubt, please use the re-index approach. There are also some other limitations. For instance, if your index contains some complex enough expression that use collectable columns, but eventually don't really rely on the sort order for the resulting expression, Postgres will still track the dependency on the collection, even if technically any break in the collection wouldn't actually corrupt your index. So you have here an example of a somewhat artificial example of such use case, but as you can see, the index is like using like a text column and then using an MD5 on that, which still technically could be corrupted in case of collection upgrade, but then the whole expression is using the collection C with just like the raw byte. So this expression can never rely on the collection. But in that case, if the underlying collection for the text call is changed, you will get such a warning. So in such cases, you can manually clear the warning, and there won't be any issue. Another example is varchar pattern ops and text pattern ops. Sorry, there is a typo here. It should be text and varchar pattern ops. And those are known to not rely on the collection sort. So those are actually handled, and if you have such indexes, they will never raise any warning. So here are explicitly how to fix the problem if you hit the warning. So once again, the safe approach is to use a re-index. So an example is to use a re-index index on your impacted index. That may be faster than re-indexing the whole table if you have a lot of indexes and only a few of them are impacted. And if you are really sure of what you're doing, you can clear the warning using the new alter index, alter collection refresh version. So once again, this can hide corruption. So make sure you really know what you're doing if you're using that. So what can be done on top of this new infrastructure to improve the situation? One thing is a patch is already submitted to introduce new option in index and non-index DB to only process indexes that may be corrupted due to outdated collection. So this will ease the DBA work after an update because they will be able to simply run like index DB dash job equal a lot and filtering that, and it will do everything automatically as fast as possible. There are also some discussion on having a similar approach to track version dependency, but for different kind of objects. As far as I know, there are no submitted proposed patch for now, but it may happen in the next development cycle. So thank you. If you have any question, you can join me with on my blog, on my Twitter, or otherwise I will be available for the Q&A session. Thank you very much.
Now we have Julian here connected, and he will answer our questions. Please write the questions in Telegram or in the chat on the platform, and I will translate them to him. So we have one question in the chat. The question is about different collation in various versions of Ubuntu. So Alexander Nikitin writes that he made a sorting of strings 11, 11, or 1-1, and the order is different in Ubuntu 14, 18, and 20. Does it mean that if he upgrades the operation system from Ubuntu 14 to Ubuntu 20, he need to make reindexing?
That's quite likely. So in case of Ubuntu, so it's Linux, probably most of the indexes are using glibc. So you have to check the glibc version, so you can do like dbkg-l and see the version of glibc. And if it's different, likely you have to do a global reindex. And the same if you are using ICU. Now, if you have a lot of indexes and it's taking a lot of space, you can try to check for the specific collection you are using. Maybe there won't be the order won't be changed and you'll be safe, but you really have to be careful and check for each specific collection how it changed in the different version. And if one Ubuntu version is below glibc 2.28 and one version is above, like almost all collection were changed, and you are probably sure that all your index are corrupted, and there is no way you have to reindex everything.
Okay, Julian, is it possible to have simultaneously two different versions of collation, for example, with two different versions of ICU library inside Postgres, inside one instance?
Not inside Postgres. You can have multiple in your operating system, and some program can use like a version API, but Postgres is not relying on that, so that's not possible right now.
But it could be useful to make some seamless upgrades of the collation versions, maybe.
It could be, yes. I think there was a thread with Peter Geoghegan. I'm not sure why it didn't happen. I think it's like a heavy modification to make that work, and maybe you need to rely on some specific packages on the operating system, but like right now it's not possible, and yes, it would be good, but I don't know why it's not like that.
Probably it's not easy to do. Yeah. So next question. why don't we fix the collation just inside Postgres? Why don't we use built-in collection tables? It can be more reliable than basing on some external resources such as libc or ICU.
Oh, it's because it's like a project in itself, and ICU is actually a bigger project than PostgreSQL. So there is none of the contributor is actually like an expert in collation, and it requires a lot of work to make it work. So it's easier to just rely on external collection library, especially ICU. It's very powerful. You can specify, like, there is a specific naming for the collation, and you can have like a natural sorting for numbers, which can be useful. You can also have like a case insensitive collation and stuff like that. So it's really a good thing to be able to rely on external libraries.
Okay, I see. What happens to replication if version of collation libraries is different between master and replica?
If it's different, likely you will have your replica will be broken. So if you run some queries on your replica, you can get like wrong results, different results, depending on what specific collection library you have on the replica. But it happened quite often on the mailing list. People are saying, oh, I don't understand on my replica. I always never see the row, and I can reindex as many times as I want, and it never shows up. And the answer is always different version of glibc or ICU.
So what is the best scenario for such an upgrade when you have a cluster of, say, one master and one replica, and you want to upgrade libc or ICU version? So if you reindex on master, so then this index may become embedded for slave.
And you want to do like almost no shutdown upgrade. That's tricky. I don't think you can actually do that because at some point you have to switch on a version with a new version of the collection and reindex as fast as possible. So maybe you can do that with a logical replication. You can set up like a logical standby, replicate everything, upgrade to the new collection and reindex, and do a switchover, and then build a physical replica from that. But it's a lot of work, and you still have some like caveats on logical replication, like DDL is not replicated. Sequence can be a bit problematic. So it's a big project. You have to check for everything, but you can do that this way, but it will take a lot of time, like beforehand, and to run everything. So you just trade like maybe half an hour or an hour or downtime for like weeks of works outside to have like a minimal shutdown.
Okay, thank you. So better, in some cases, better is not to upgrade anything. Just if it works, don't touch it. Okay, thank you very much, Julien.
Thank you.
It's a very hot topic, especially for Russian language, because we have our own alphabet and our own collation and so on. Yeah, thank you. Now, Julien, there is a special chat on the conference platform when you can chat with other participants. Maybe you will get some questions there. So now, sure. Please proceed there. Thank you very much. And for everybody, I want to once more to remind that we have lightning talks. And Julien, maybe you want to apply for a lightning talk. The lightning talk session will be tomorrow before the conference closing. So you may submit your lightning talk at the conference platform at a special page. And probably all the lightning talks will be accepted, and you will have 5 minutes to speak tomorrow. Okay, and please don't forget to rate the talks you listen to. Don't forget to give your star to Julien, because he worked good. So thank you very much, Julien.
Спасибо.
Yeah. See you and welcome.
Bye-bye.
Good day. My name is Arseny, and I will accompany you till the end of this day. This is still PGConf.Online 2021, and our next speaker is Daniel Varazza. Daniel is Italian software developer who is PsychoPG2 maintainer for more than 10 years now, and PsychoPG2 is technically the default driver between Postgres and Python. The talk will be on PsychoPG3, the next generation of it, which supports asynchronous programming, asyncio, and other cool features. And it is its development, which started in a van prowling around New Zealand, is still ongoing, and Daniel isn't doing any more commercial software development. So I think I should say here that you can contribute to the future of Postgres and Python by funding Daniel, and thus funding PsychoPG3 development. Right, so this talk is pre-recorded. You can ask questions in the chat, and I hope Daniel will be around to answer them. And now let the talk begin.
Good morning, everyone, or good afternoon. My name is Daniele. I've been the maintainer of PsychoPG2, which is, you might know, the most used adapter for between Python and PostgreSQL. And I've recently started a new project, which will be the successor of that, PsychoPG3. And I would like to explain you why is that and what do we want to do with it. So first, a word about PsychoPG2. It is the most used adapter currently on the market. There are other ones, but they haven't picked up with usage. Probably the reason is a good structure of PsychoPG2. It is libpq based, which means that in order to communicate with the server, it uses the libpq, which is the official client library for Postgres. It's written by the same Postgres authors, so we can expect it to be efficient and reliable. And it's relatively fast. It's quite fast because half of the project is written in C. Everything wrapping the libpq is written in C, so has good performance. And it's been around for a relatively long time because probably it's been in production since 2005, so it's been good for a good 15 years. And so far it's been well, but with the time there are some problems that are appearing in the system. Some of the first hours choices turned out to be not the best ones, and the systems are evolved in this time. For instance, in Python, there is now widely used async.io, asynchronous framework for network communication, and we don't wrap some important features. For instance, there's a big request for prepared segments, and they're very hard to introduce in PsychoPG2. And still people is baffled that by the fact that we do PsychoPG2 does client-side binding. So all in all, there are a few things that should be addressed in order to have this adapter working well for the current times. Looking a bit better to the problems on the Postgres side, the way PsychoPG2 is client-side binding. This means that if you have a query with placeholders and you have a bunch of values in Python, the adapter will convert every value into a snippet of SQL. It could be a literal, or it could be something a bit more complicated. For instance, a string get quoted, quotes into the string get escaped, different types adapt in different ways, and all in all, the two things are merged together into a single query on the server. So the server receives a single message that contains the query and the parameters already bound. Because we do that instead of asking the clients to do that, this is safe. It's not a safety issue. However, this way of composing arguments creates problems in composing with other things. For instance, in this format, we cannot use copy because copy wouldn't want the quotes and the escaping of values. It would require a different format. For the same reason, we cannot do prepare transaction because we would need a different way of passing values. So instead of using this simple function that sends everything together, we should use a more complex function to send queries to the server. One function on the family of exec params, meaning that we need to specify the placeholders in Postgres formats, which is $1, $2. Possibly we should specify the types of the values. The parameters don't take the quoting, don't take the quote escaping. And we can also specify whether we want to pass parameters or receive the results in text formats or in binary formats. So all in all, it's a very different way to send queries. On the Python side, there are things that can be improved as well. This is especially because Python in the last 15 years has changed a lot as a language. One important thing, as we said, is that there is this asynchronous driver that demands a different syntax for the functions in order to be used. So PsychoPG2 is designed following a standard that is called DBAPI2, and this standard demands blocking functions. So connect is a function that blocks until a connection is ready. Execute is a function that blocks until a query is finished. In order to use async.io, we need a different function, and the way PsychoPG2 already supports concurrency, which is multi-threading or green thread using eventlets, don't work with async.io. PsychoPG2 is already asynchronous, by the way, as a synchronous way of working, just not a standard way. So if you want to build something asynchronous, you have to synchronize it using selects or repo or some other way. So it doesn't participate well to this new framework. Other choices which were made a long time ago, PsychoPG2 predates the use of with, and it uses with in a way that is not considered standard anymore. So for instance, people expect that with connects would close the connection at the end of the block, and PsychoPG2 only closes the transaction instead. It could be considered a good idea, but is not familiar. And the connection pool doesn't support the with statement at all, which makes hard to use, and it's not easy to implement it because of the way the connection works. So all in all, with this experience, the experience of maintaining PsychoPG2 over the years made so that when I stopped working back in February last year, I decided that before jumping into a new job, I wanted to give it a go and put together this project. So things started timidly in March 2020 in probably the first commit of the adapter have been done in a camper van during a holiday in New Zealand. And after some time in which the project has been developed as a side job, I started working full-time on it since about October. And hopefully the project should be completed, at least a feature complete package, and distributed on PyPy probably in a couple of months. So we're talking about probably April 2021. This project has been my main job in this moment, so it would be good to have some contribution. That could be either someone who might want to collaborate to the project or some financial contribution. So we are happy to have some sponsors, and among the sponsors, I'd like to thank Postgres Professional and Command Prompts, which are the two main ones. So, what do we want for this project? Fundamentally, is the list, the easiest migration path coming from PsychoPG2. The idea of PsychoPG3 is to be used. So I would like that for simple cases, the way of introducing it into a project is as simple as using a different package name. This is fundamentally the reason why the major version number is written in the package. This allows also transition time in which in the same program both PsychoPG2 and 3 can be used. So ideally, apart from the module name, the basic way of working with the adapter is unchanged. However, there is a lot of possibility to improve the interface. So things that in PsychoPG2 were done in a way that's it is mandated by the standard, but it's probably not the most comfortable one. Now we can use much more idiomatic way of working, for instance, using with in order to open a connection and expect it to be closed at the end. We can use the cursor again as a block. We can concatenate a fetch statement, a fetch command after an execute, and we can even work directly querying on the connection itself, which is a much more familiar way of working, coming, for instance, from PSQL, where people opens a connection and they expect to be able to send commands to the connection and read directly the results. So this is what we want to do. Let's take a look. Let's geek out a little bit on the design and how this is implemented. Internally, PsychoPG2 is built around a wrapper for the libpq. We said this is the standard client library for Postgres. It is a pure C library, which means it only exposes functions and structures and constants. And PsychoPG3 wraps it into an internal module, the module psychopg3.pq, which wraps completely all the function exposed by the libpq, not only the one that PsychoPG uses itself. So all those functions are given a object interface so that the object lifetime can be tied to the memory allocation. And because this interface is complete, it can even be used by other programs if they want to have a low-level access to the libpq, but in Python. And it could be used to design new different adapters. This module, the .pq module, is actually an interface, and there are different implementations for this interface. There is a basic one, which is written in Python, and it has relatively weak performance because it uses foreign interface in order to call the C functions. However, it doesn't require a compiler in order to use PsychoPG on a client. Other two modules are, well, the most important one is a module written in Cython, which is a language that transpiles to C, so it's pretty much written in C. And this offers a very fast conversion between Python and libpq functions. This requires a compiler to be present where the client is used. And the intention is also to distribute a version of the latter one in a binary format. Installing it would need no compiler, no libpq on the client because it would package everything. this is a possibility that is only supported on certain Python distributions, but where it's supported, it can be used. And so using pip, it would be possible to implementation of the libreq wrapper to use and use a performing one if it's possible to use, or fall back on a simpler one. Another area that needs a little bit of study is around the fact that now we need to support two different interfaces, because the blocking version of execute and the asynchronous version are effectively two different functions with two different signatures. And so if we did a naive implementation of the two, we would end up with a lot of duplicate code and possibly bugs manifesting only on one implementation and not in the other. So in order to make sure that the two versions work exactly the same way, work as much as possible in the same way, all the interaction with the libpq and all the state managements of the most complex objects, such as the connection or the cursor, is done using generators, where the protocol, which is the sequence of the functions to call, is implemented as a generator, which would yield a message in a moment in which they would block. So pretty much this is a non-blocking generator, and whenever it blocks because it's waiting, for instance, for values for data coming from the network, it would yield a value saying, I need to wait for writing. This way, the how to wait, the waiting policy, is actually the only thing that is demanded to implement to the outermost classes. So for instance, a blocking connection would use a blocking lock and would use epoll or select in order to wait for the file descriptor of the connection to be ready. The asynchronous one instead would use an async IO friendly lock, and it would use a way of waiting for the file descriptor to be ready. There is collaborating together with the other file descriptor in the events loop of async IO. And this also makes easy to port PsychoPG3 to other implementation. For instance, there is another new asynchronous framework which is called Trio. I don't know much about it, but taking a look at it, probably it's only necessary to implement a waiting function for Trio in order to have the entire PsychoPG internal code already working with this other framework. And same with eventlet of G events if we want to do an explicit porting instead of relying on monkey patching. Because we have a completely different way of passing values to Postgres, the adaptation layer is also very different in PsychoPG3. Other problems that manifested in PsychoPG2 were related to performance, because PsychoPG2 used to do heavy use of wrappers, and when there were a lot of objects like arrays of numbers, every single number had to be wrapped into a structure that had to be allocated, etc. So it was relatively slow in dumping a lot of objects. One of the problems was the lack of an explicit concept of now I'm working on a query, so certain things won't change. For instance, the connection encoding might change from one query to the other, but within the same query will not change. So if we have an object to manage the entire passing the query, receiving the results, we have the possibility of caching temporarily a lot of values and have a much better performance CPU-wise. So in PsychoPG3, there is now a transformer object, which is responsible of the entire data transformation. The a transformer is used whenever there is, for instance, a query running. And the first step it does, it takes the parameters to be sent to Postgres and uses a series of dumpers in order to convert them in the right format. Step 2, the values and the query are sent to the server. And when the server gives back us a result, the result is given to the transformer, which is then able to instantiate the right loaders, which are the bits that will convert the Postgres value into Python. And so at fetch operation, those Python values can be given to the client that is expecting them. And because the same transformer object is used whenever there is the need to convert something, for instance, not only just in query, but also in a copy operation or adapting recursive types like structures, composite types, the same object and the same policy of transformation is used. So the results are consistent in different cases. Dumpers are the thing that has changed most, because in PG2, because we could write a query, we could get away with doing a lot of things. We didn't have to associate a real value to every Python object. We could have associated as, for instance, a snippet of SQL. So we could have used a constructor like array with the square brackets, which are not recognized as valid in using the server-side binding. So we have to give very precise values and also associate them with metadata, such as the OID of the type. Because otherwise, Postgres might not be able to infer what type is that we're talking about in certain context, and that would require a lot of queries to be written, and that means that using PG3 would be much more difficult than using 2. In the past, everything that we were doing in order to decide how to convert a value was to look at its Python type. So once we see a number, we know that we can adapt it as a number, and we can write down the number as a string, and it wouldn't change how long is the number. Now that we are using separate value, this becomes an important detail, for instance, for numbers, because if we use a too small value, a too small data type, we risk an overflow, and if we use a larger one, Postgres will refuse to make a cast. Unfortunately, we have to use the right one, or maybe a small one, but not a larger one. So only using the class of the integer is not enough anymore to pass numbers to Postgres. So in PG3, those dumpers, those objects which convert Python to Postgres, now work in a two-steps fashion. So certain dumpers, for instance, the numbers one, the integers one, is instantiated when we see Python int. But then the transformer will ask it if it wants to specialize further by passing its value. So for instance, if we have a small value, we can use a 2 bytes integer. If we use a large number, for instance, 100,000, it doesn't fit into 2 bytes, so it would use 4 bytes. That means it would use a different binary format, it would use a different OID. Not all the dumpers need that, only certain ones. For instance, text dumper, every text, whatever the length or the contents, is converted the same way, so we don't need to do this double step. But several objects require. For instance, Python datetime could be time zone aware or time zone naive. And in Postgres, there are two different types, and not always there is an implicit cast between the two. So we better choose the right one when we pass the value to Postgres. Or Python lists. List is a list. It doesn't have further types, whereas in Postgres, we have arrays, distinct arrays for distinct types. That means that in order to understand what is the right type of a list, we have to look into its content, to look for its values and decide which is the best type, which is the best ID to use. The other way around is simpler, because just looking at the Postgres ID of the values is already enough to create objects that are able to convert whatever is given them to a Python value. However, now there is a more precise concept of instantiating a loader which can have a state, and because there is the transformer that is responsible for the conversion, we can organize the code path in a way that makes transformation much more efficient. So these are a few highlights of the internal structure. Now let's take a look. Now that we have the stuff, what we can do. The one I've mentioned lots of times already is the support for async IO. This is really important strategically because a lot of new stuff is coming in Python, and a lot of that is based on async IO. Everywhere there is concurrency, writing a server-side service, more and more it's being written in async IO. So PsychoPG3 is able not only to support the current framework, Flask or Django, but the idea would be also to support new ones such as FastAPI, which is a very, very nice query, very nice framework that is getting more and more used to write JSON-based API servers. At the moment, there is a wrapper to use it with PsychoPG2, but the idea would be to have PsychoPG3 to be able to participate to FastAPI in the most simple way. Another nice feature that we have added, because now the with statement on the connection is only used to close the connection, is that now we can have transactions as explicit blocks. So we have a new method on connection called transaction, which starts a new transaction, and we can expect that at the end of the block, the transaction will be committed or will be rolled back. And this block is also possible to nest this block. So open a transaction into a transaction. Internally, nested transactions are implemented using save points. So we can have a very nice and visual way to visualize and to map transaction life to the code, to the shape of the code in Python. We can have internal transactions that might fail or succeed, and the external one, the outermost one, succeed anyway. For instance, we can even throw an exception to roll back a certain transaction and keep on working at the end of the block. So this was a very nice feature to implement. I had a lot of help from Daniel Fortunov, who is the author of a previous module for managing nested transaction for PsychoPG2. So Daniel had a lot of experience already with this problem, and so we designed a very nice feature for PsychoPG3. Another thing that I'm really happy to support is now a proper support for copy, because in PsychoPG2 copy was only based on files, so fundamentally you couldn't do much more compared to use copy in PSQL. You could have used transactional things together, but it wasn't an easy support, and creating the data for copying was left to the user. Now copy is based on Python objects. So if you have an iterable in Python, for instance, a list of objects, a list of tuples, now it's possible to use a copy block, and within this copy block, it's possible to send data using the copy format, which is the most efficient way to load data into the database, directly starting from the Python values and using the adaptation system that is used for normal querying of normal parameter passing in the database. So copy now is a block. It supports copy in both the directions. It supports both reading data or reading a pre-formatted value. It supports both text formats and binary formats. So it's quite a good coverage, quite a complete coverage of all the possibilities that is used. And of course, it's asynchronous too. Supporting copy in asynchronous mode is something that PGConf didn't do, and it was a very important feature for which we had a lot of requests, but for the sake of PGConf design, it was very hard to introduce. New ways of using a existing but difficult feature is with the asynchronous notifications. They work not only in async IO, they work also in an asynchronous way. Asynchronous notifications are support for when the server want to send signals to a client. Again, this was supported in PGConf, but it was difficult to use. You had to use file completion and select. Now it's much more easier. There is a generator which generates notifies, so people can now write a program or a part of the program, one single thread, for instance, which would use a connection only to receive notifications from the server. As soon as another external process uses a notify statements, this connection would return an object that can be used, for instance, in Python to receive this message, decide to update something, or to send this message to propagate this signal into the rest of a larger system. So I think this is an important feature. In a lot of complex program, it's very useful to receive asynchronous notifications from the server, and now it's probably much easier to use this feature. One of the most requested things was around the prepare statements. They were very hard to use earlier because the adaptation system wasn't doing the right thing, was talking in a different language. Now they are so used that they are pretty much automatic. So by default, using the same query with different parameters in the same connection, eventually the statement will be prepared, and so for further queries, the steps of parsing the statements of preparing the plan will be already cached in the server. So from test, it works pretty much transparently, so it is enabled by default. But if people want, they can configure it and decide that whether they will always want preparing or they don't want preparing. And there is a limit to avoid that runaway program generating always different queries would end up clogging the system with that. So there is a maximum number of queries prepared, and the least recently used ones are cleaned, so that both the client and the server don't have a excessive usage of memory caused by too many queries, too many different queries. Right now, just in this moment, I'm working on a new connection pool because the connection pool is in PsychoPG2 was quite a weak object. It didn't have a good behavior. So I've been looking around for other implementations, and I found the ideas used in other languages and platforms. For instance, in Java, there is a connection pool, very opinionated, very nice, which is called the Hikari CP. And I've taken some inspiration from the features they support, the way they have it to configure, the behavior of the pool. So now there is a much more predictable pool where asking too many connection doesn't give an error like it does now, but it leaves the clients to waiting with the timeout so that there is some back pressure, and if there is an excessive amount of requests, eventually the callers start failing. There are background workers so that the connection can be maintained and checked for health in the background. And again, it can be used finally as a context manager, so people can use the with syntax in order to take a connection from the pool, and they are sure that either it's a success or an error, but at the end of the block, the connection will be returned to the pool, so there is no problem with connection leaking or getting lost. And nicely, PsychoPG3 is already being used as a test bed for some features that are not current. They're not currently in Postgres, but they are up and coming, so they could probably shape the way that we will use Postgres or other databases in the future. One interesting features that Postgres doesn't support, but a few Postgres-derived databases do, is the concept of a query that never ends. So using a query as a stream. Postgres currently, as the only way of running a query, is getting a result with a known number of records. However, the network protocol doesn't mandate it. And there are a few alternative implementations of Postgres that make use of these in order to create an endless stream of info or data, or at least it will be closed eventually, but it's not declared from the beginning how many rows there will be. And the rows come one at a time. Of course, it's not a stream of rows, but for instance, whenever there is a change, a new record will be generated in the stream. So PsychoPG uses the libpq single row mode, and as a new method that is cursor.stream, it runs a query, it receives the results, but instead of expecting the entire results to be transferred, it works as a generator so that the lines can be consumed one at a time as they're coming. And this is a pretty experimental feature. It's experimental both in the servers and the clients. At the moment, CockroachDB has a change feed feature for that creates the stream, materialized database as the tail formats, and I'm having a chat with those people, and they are testing this feature, and seems like it's working nicely. Another thing that is not there yet, but almost, is a pipeline mode for sending queries. This requires a change that is currently in the commit fest and scheduled for Postgres 14. This is not a change in the server. It's only a change in the libpq, because the server and the wire protocol already support the concept of sending queries before the results of a previous query has returned. However, the libpq doesn't support it and forces a result to be completely consumed before being able to send a new query. So we are waiting for this patch to land in the LibPQ and enable this different way of working, because if this is done, then instead of having a lock on the connection to serialize concurrent access, we can, instead having a couple of queues, and we can have a number of clients sending queries at the same time to the same connection, and the connection sending data, and as soon as the result is ready, shipping it back to the clients that requested it. So the expectation is that the performance in concurrent situation using these different ways of sending parameters would be much better, and we would be able to use every single connection much more efficiently than the way they are currently is possible with the current LibPQ limitation of a single query at a time. And other area where there is a lot of improvements on the way is around JSON-B. Oleg and Postgres Pro are doing a lot of work around JSON-B. And inside the server, the JSON-B data type has obtained a lot of improvements. However, JSON-B is sent to the clients still in text formats, which is probably a performance impact, because on sending, the server has to escape all the strings, create a larger data structure with the JSON contents, and on the clients, we need to parse JSON using from the text format, which means unescaping the string, checking for validity. It's probably a harder work to do. So we are experimenting together with the Postgres Pro team with a way of sending JSON-B in binary to the clients. We did some preliminary tests in which we didn't create a format, but what we did was to send the disk format to the clients and parse the disk format on the client instead of on the server. And the results are really interesting, because playing a little bit with, let's say, in the order of the hundred of megabytes, the performance seemed in the order of 4 times better than parsing JSON-B, than receiving JSON-B in using the standard Python module, and even using the fastest available parser for JSON on the client is still much more efficient to recreate Python structure starting from the binary structure of the JSON-B. Now, this is not a really scientific benchmark. It was some quick benchmark to test a proof of concept. Also, JSON-B is not necessarily a good format. The disk format is not really a portable format, because it might depend on the server architecture. So whether numbers, for instance, are big endian or small endian, it depends on the server instead of being explicited in a protocol. So probably this will require some more work, either to make sure to be able to receive every information we need to recreate the data exactly as it is in the server, or we could use a binary format. However, PGC is already being used as a test base because of its flexible adaptation system to try with different possibilities for data transfer between server and clients. So this is what I wanted to show you about PGC. Now I understand there is the possibility of asking some questions, so I'm happy to receive them. And thank you very much for listening so far.
Okay. Welcome, Daniel.
Hello.
Thank you very much for your talk. It went smooth, and you have covered almost everything I wanted to know about.
Good.
Python driver, full mode, and batch mode. Would you like to comment some more on any of the questions in the chat? You seem to have answered already.
Yeah, I think I answered, but I don't know, maybe because saying those questions the first time, and they could be something that we haven't thought about. So I invite whoever has doubts about the ideas that have been exposed there, or the implementation, the choices. I invite people to have a conversation. So there is either the mailing list, psychopg@postgres.org, at postgresql.org, or on the backtracker on the psychopg3 project on GitHub. So we are still in time to make changes, because the project, of course, is not widely used, and whoever is using now knows that things might break. So it's a good time to nail the choices the right way, so that don't get in the way for people wanting to use them.
Okay, thank you. You are inviting people to check, the current status and.
Yeah. Also, if I've seen, for instance, someone who has a question about if it's possible to disable save points. I don't know if it's a good idea or not. I didn't think about that. So it could be that if explained better, it could be maybe a good thing to do. So I invite those people having those questions to ask better in the channels. So in the channel where other people can participate to the conversation.
Okay, thank you. As a core developer, I can say that Postgres experiences some problems when there are a lot of save points, because the internal data structure which serves them is not scalable.
Yeah, no, that's the save points are not used automatically. They're only used if people use a transaction inside a transaction. So the first thing I have to say is just don't use it if you are going to use it in a very heavy way. But then it could be that there are reasons for which it's a bad idea anyway, and someone was suggesting to kind of disallow it, would mean probably throwing an exception. So there is a balance. If we make a thing that is so much configurable, then it's complex to use. Ideally, the default choice should be the right one, and then possibly there should be ways to override it, but even not so many, because then there is an explosion in complexity in the internal behavior. Maybe there are, if 3 options are one way and 1 option is another, then there is a bug that verifies. So I want to understand if this is a genuinely useful use case, in which case we can to customize this work, and we want to understand better what is the right default for it.
Yes, of course. Right. One new question about large objects, how to do work with them more simple.
I haven't started working with the large objects yet in psychopg3. In psychopg2, they're exposed as files, which seems a good interface, so that people don't have to fetch them entirely like they were Vitae fields. I am not a heavy user of them, so I don't have a perception whether the psychopg2 interface is wrong. And I would invite people who use large objects and have found problem in psychopg2 to tell us the reason why that interface is wrong, and we can design a new interface for it. I told you, as my intuition, what I would have done is mostly, more or less, to port the same interface. So provide a function that returns an object that is a file-like object in Python, and allow people to use it. But happy to hear if that's the wrong choice. I better hear from others, because not being a heavy user of those objects, I might not
probably
be aware of the problems.
It intersects with the idea of streaming query, because you have a handle which streams data.
Honestly, it's a part of PsychoPG3 that I haven't yet attacked. I haven't really thought about it, so totally open to have a conversation about what's the best interface to implement them. Otherwise, I would go with something similar to PsychoPG2.
Okay, one more question. Why had you create your own connection pooler? Because PG Bouncer is very standard. Well, no.
Yeah, PG Bouncer, though, it's still an external process. So you still need a round trip with an external process in order to get a new connection, even if it's cheaper than establishing a new connection. I've seen that, my current use case when I use PsychoPG as a developer of something larger than it is usually nowadays is writing web services. So I have a big need of having something that provides me a connection and where I can give back a connection when it's finished, and that it's fast, is available. It doesn't add complexity to it, and PsychoPG2 has a pool, but it's badly designed, mostly because it was designed with the use case of Zopi, Python framework that not many people use anymore, and it was designed around its use case. It doesn't have a good behavior. It's not very reliable. As in, if you ask too many connections, it will give an error eventually. And the saner behavior would be to let a client wait until a timeout pass and give it an exception. That would be much saner way of working. And so the pool that is being implemented is this way. It has a queue of clients. So if a connection is not immediately available, they can wait. They will get back an error if, for instance, after 30 seconds, configurable, of course, there is not a connection ready. And the problem I have with this pool, I've been thought for a while about having it in PsychoPG3 or not. Because anyway, in order to be good, efficient, has to be sort of alive. It has to have a maintainer thread, for instance, because when you want a connection, maybe you don't want to wait for a new connection to be created. But on the same time, it doesn't have to make too many choices itself, because it's still a library. It's not a program itself. It has to play ball with whoever wants to use it. So I guess it's even more complex to draw a fine line between being useful and not take too much initiative into behavior that then don't work with the program someone is writing. Yes. So yeah, anyway, what I would like to have is a thing where I import PsychoPG3, I have a pool available, and I have a few connections, 4 connections, as many I need locally, and I don't have to create another piece of infrastructure. It doesn't replace PG Bouncer, but it allows for a pool in process rather than out of process and another piece of infrastructure.
I also have a stupid question about the origin of the name. I think I once tried to Google it up, but failed. So
I don't know. Well, no, I know from probably an interview. I'm not the original author of PsychoPG. I got involved in the project in the early days of PsychoPG2. the original author, I think I read an interview from him. And I said that his company was creating, we're talking about times in which Python wasn't so used, and they were creating the first interface, and they had something very complex in mind, which would have been a sort of like an external process with a connection pool. And he put together a sort of prototype that then it eventually became Psycho PG1 list, and it was crazy fast. He said,
okay.
So it was some fun related to being unexpectedly crazy fast and something like this. And yeah, I don't know, it's another familiar name. I once met a person who said, I was working in Canonical, and said, yeah, I maintain the driver within Python and Postgres, and he said, you maintain Psycho Pig. So yes.
Yes, of course.
Yes, that one.
Right, so thank you very much. I think it's high time because the next talk will begin in 4 minutes. People who want to ask more questions.
Yeah, I'll be in the chat. There,
yeah.
and then all the other channels are open for other questions whenever you want.
So you can discuss in the special chat and in text chat also. I also remind that we have lightning talks tomorrow. So if anyone has nice subject he wants to talk about for 5 minutes, you are welcome. And I also remind you that you can star the talks you like, the platform. So now a short break for 4 minutes. Thank you very much, Daniel. And
thank you.
Let's go for the, see you later.
Bye-bye.
Thank you.
Человека. Стремление создавать. Мы создаем невероятное, создаем новые возможности и верим в успех. Ведь благодаря искусственному интеллекту, облачным технологиям и 5G от Intel осуществимы даже самые смелые мечты. Мы создаем то, что вчера не могли и представить. А сколько еще впереди?
So what are we gonna do about it?
Давайте создавать то, о чем мечтают люди. Реально ли это? Реально, если мы вместе. Ведь нужна лишь идея и технологии Intel, чтобы создавать удивительное.
Okay, this is PGConf.Online 2021. We move forward. This talk is going to be the last for today. The speaker is Robert Haas, and I think he hardly needs any introduction. He's major contributor to Postgres since 2008. He is vice president and chief database architect at Enterprise DB and so on. Personally, I can say that I'm excited. I enjoy the high style of English with which Robert conducts the correspondence in hackers' mailing lists and attentive to the language details. Today he will talk about avoiding, detecting if you hadn't avoided, and recovering from database corruption if you hadn't detected, or if you have detected anyway. So let's start. Robert, welcome.
Hi everyone, my name is Robert Haas, and this is my talk on avoiding, detecting, and recovering from database corruption. Just by way of introduction, I am a fairly long-time PostgreSQL hacker. I've been participating on the mailing list for about 13 years now, and this is my first time speaking at the Russian PostgreSQL event, so I'd like to thank the organizers for the opportunity. For my day job, I work at EDB as the chief database scientist. I'm always a little afraid that when I give talks like this, people will start to get the idea that database corruption is something that happens in PostgreSQL all the time. And I don't really think that's true. I think that actually it's a pretty reliable system and most people have a good experience. But because I work at a company where we provide a lot of support to users of PostgreSQL, and because people tend to report their most serious problems to us, I actually encounter these kinds of problems pretty frequently. So just by way of agenda, I'm going to start by giving a quick definition of corruption. Then I'm going to talk about some of the causes of corruption, some best practices that you can follow to avoid having your database get corrupted and to detect the fact that it has become corrupted if that happens. We'll talk about signs that it has happened. And finally, we'll offer a few ideas about how you might be able to recover from the situation if it does happen to you. So in terms of a definition of corruption, the best thing that I could come up with is to say that corruption means that the database contents have been altered in some way. And specifically, they've been altered in such a way that SQL statements behave in a really unexpected manner relative to the other SQL statements that have been previously executed. So, for example, if we store some data into a table using an insert command, our reasonable expectation is that a subsequent select command will return the same data that we stored, assuming, of course, that we haven't modified it since it was originally stored. So if that's the case, and if we get back different data than what we originally put into the database, that is corruption. If we get an error or a crash, that's also corruption, provided that the reason why those things are happening is because of some unexpected alteration to the contents of the database. If that's not the issue, if the database hasn't been altered, or if that's not the reason for the problem, then we might just have a plain old bug. But for this talk, we're going to be focusing on the corruption case. In general, there are sort of three possible ways that database corruption could happen. So first of all, you might have a problem with your hardware. Things are pretty common. Disks go bad quite frequently. Memory goes bad much less frequently, but there have been a couple of documented cases during my time at EDB where a customer had a problem with database corruption and it was eventually tracked back to bad memory so that the contents of the database got corrupted even before the data was written to disk. And of course, all software has bugs, or at least all software that's at all complicated has bugs. PostgreSQL has bugs, your operating system kernel has bugs, your file system and your backup tool have bugs. Everything has bugs. So sometimes those bugs may result in database corruption. And finally, people do things themselves all the time to corrupt their databases. Probably one of the most common examples is people who perform backups or recovery from backups in a way that does not match what the documentation says that you should do, and they end up with a corrupted database. But there are a variety of other things as well, and we'll talk a little bit about that as we move through the rest of the talk. So we're going to talk about best practices for detecting and avoiding corruption. Of course, you can't completely avoid corruption no matter what you do, and you can't be completely sure of detecting corruption no matter what you do. But there are things that you can do to improve your chances. So I've grouped some of the best practices into 4 areas, and we'll just go through each one individually. So first of all, backup and restore. The most important thing here is that you actually need to take backups, and you need to take them regularly. And there are 2 reasons why this is important from the standpoint of database corruption. I think one of those reasons is pretty obvious, and that is that if you do have some kind of database corruption, but you have a backup which is not corrupted, then you may be able to get your data back from the backup, and in that way you may be able to avoid any sort of permanent data loss. But there's a second advantage to this too, which is that taking a backup basically means that you're going to copy your entire database. And if you make a copy of your entire database, that proves that all of the data is readable. It does not prove that all of the data is correct, that the data that you read off the disk is the same as the data that was written to the disk. But it at least proves that you can read something from the disk, which is not something that you want to take for granted because, again, disks go bad all the time. It's not enough to just take a backup, of course. You also need to make sure that you can restore the backup, and you want to verify that the restored backup looks okay. After you restore the backup, you should check that all of your data seems to be there, that you can run some sample queries against it, and that it looks like you have what you expect to have in terms of the database having the proper contents. If you don't check these things, then they might turn out not to be true. And the time when they turn out not to be true is the time when you really need them to be true. So you should really, test these things on a somewhat regular basis and be sure that everything seems to be working the way that you think it should be working. My final piece of advice in this area, and I think this is really important, is that you want to use a good professionally written backup tool rather than a homegrown script. I am always really surprised by the number of people who seem to be doing their backups and restores using scripts that they wrote themselves. And a lot of those scripts are not very good. I've seen quite a few of these scripts that people have written for their own environment where there are no error checks, which is really bad when you're talking about something that is as critical as taking a backup. Now, if you use one of the various backup tools that are available for PostgreSQL, that doesn't guarantee that you're not going to have a problem. After all, that backup and restore software is pretty complicated, and it too can have bugs, and almost certainly has some bugs somewhere that could affect the integrity of your data. However, it's likely that a person whose job it is to write a backup tool, or who has spent a lot of time working on a backup tool, may have done a better job with it than you would be able to do yourself. Especially if that person is also more knowledgeable about PostgreSQL than you are. And hopefully that backup tool that they've written is in use in a large number of PostgreSQL instances, and therefore whatever bugs it had in the first version, hopefully at least the most serious ones have been found and fixed by now. So I really strongly recommend that you go around and figure out which of the various backup tools that are available for PostgreSQL is best for your needs, and make use of that rather than rolling your own procedure. Moving on to configuration, there are 3 settings in PostgreSQL.conf which have an effect on the ability of the system to survive an operating system crash without data loss. The first 2 are pretty simple because the defaults are safe and you should just never change them. fsync should always be turned on. If you turn fsync off and you have a crash, you are very likely to end up with a corrupted database. One particular thing that people sometimes do is they turn off fsync during the initial load, hoping to speed things up, and they forget to turn it back on afterward, and then months or years later they have a crash and they end up with a corrupted database. I don't know that it's really worth it. I think you should just always leave this on. It's true that you may be able to improve performance somewhat by turning it off temporarily in certain circumstances, but the performance gains by and large are not going to be that much, and I'm not sure it's sufficient to compensate you for the possibility that you're going to make a mistake and end up with a corrupted database. Full page writes is another setting where the default is on, and you should always leave it turned on. There are theoretical circumstances under which it can be safe to turn this off, and I certainly understand the appeal of that because there can be significant performance benefits from that, but in practice, it's never safe. The theoretical environment where everything uses the exact same page size and all of the writes are atomic is just not a real world scenario that ever happens. And you really need to keep this turned on, or again, you risk having data corruption following an operating system crash. The final PostgreSQL.conf setting that we're going to talk about here is a little bit more complicated, and unfortunately the default is not necessarily safe. For example, on Mac OS X, the default value of this setting is fsync, but fsync is not actually safe on Mac OS. You need to use the fsync write-through setting. I am not an expert on Windows, but I have been told by people who are that if you are running on Windows, you need to use either fsync or fsync write-through, or disable write caching on your drive. I recommend that no matter how you configure this, you check the output of the pgtest fsync utility, which is included with PostgreSQL. If you see that the method that you have chosen is 10 or 100 or 1,000 times faster than some other method, then there is a good chance that it is not really working. We rely on fsync forcing all of the dirty data out to the disk, and if it doesn't do that, then you may end up with a corrupted database in the case of an operating system crash. There's one other piece of configuration which is not part of PostgreSQL.conf, but which is really useful if you're concerned about the possibility of database corruption, and that is the checksums feature. Turning on checksums won't prevent your database from becoming corrupted, but the corruption is much more likely to be automatically detected and to produce errors that you can notice. So if you want to use this feature, you can create your database cluster using initdb-k, or if you're running version 12 or any newer version, you can shut down the database, use the pgchecksums-e command to enable checksums, and then start the database back up again, which will be quicker than a full dump and restore onto a new database cluster, which would be another way of getting checksums enabled. There is some performance overhead from this. It's small on most workloads. It could be larger on your workload. So you will want to check and see if that's a problem for you. But it's really nice in terms of being able to spot potential corruption. The big picture in terms of the storage for your database is that you want your storage stack to be as simple as possible. If you can, I recommend that you use local storage rather than a network file system. Certainly, there are people who have NFS and iSCSI configurations which have been expertly configured, and those systems are probably quite reliable, but people who have set them up poorly and end up with something unreliable seem to be pretty common. I think that the simpler you make this, the fewer things there are that can fail. You're always going to have the disk itself, the disk controller, and the various operating system components such as the kernel and the file system, which can do something wrong and corrupt your database. But as soon as you are talking about a network file system, you have multiple servers involved, and each of those servers has a network card that's involved, and there may be a router or a switch involved, and on one of those systems, at least, you still have a disk and a disk controller and all of that stuff. Similarly, when you add things like virtualization or containerization, you're making the process by which the data that you write gets out to the disk more complicated. And every time you do that, there's a possibility that something stops working. So if you use those kinds of technologies, you really need to test carefully to make sure that you haven't broken the reliability of the system. If you do have to use NFS, you should perform the NFS export using the sync option, and I recommend that you perform the NFS mount using the v4 hard and sync options, and that you test it carefully. I do think that using RAID is a good idea. RAID 10 is a great choice for databases. You don't want to rely on RAID not to fail, and like anything else that you add to the system, it is adding complexity, so there is some risk there, because your RAID controller can fail just like your disk controller can fail. But that having been said, the really nice thing about RAID 10 is that for every disk you have another disk that is supposed to contain exactly the same contents as the first disk. And so if you find out that that's not the case and that a particular disk is unreadable or contains something other than what it should contain, that it's corrupted in some way, you can just take that disk out and you should still have a working system. You should still have a complete copy of your data. And that is a very nice place to be. There is a good deal of difference between the various file systems that are available in terms of reliability. My experience is that ext4 and XFS are extremely reliable, and that almost everything else has problems. ext3, which fortunately is no longer in widespread use, had a lot of problems that affected the reliability of the system. And I've seen multiple cases where bugs in ZFS corrupted customer data, and it was very clear that the problem could only be explained by ZFS having, at least one bug, if not several. So I am very cautious about the idea that it's okay to use some other file system with PostgreSQL. Of course it may be, and it's up to you, but I think the advantage that ext4 and XFS have is that they're extremely widely deployed. And because they're extremely widely deployed, they seem to be better debugged than many of the other systems. So even though they might be lacking some feature that you really like to have, you have to consider the advantages of using something that a lot of other people are using and that is known to be quite stable. Finally, with regard to storage, you need to monitor both the PostgreSQL logs and also the operating system logs for storage-related errors. If the operating system kernel detects something like an I/O error and it reports that to PostgreSQL, then PostgreSQL is going to log that I/O error, and so you will see that show up in the PostgreSQL log file. However, sometimes the operating system will detect a problem, but it will not report it to PostgreSQL for one reason or another. For example, it might be a soft failure. It might be something like, the data was eventually successfully written to disk, but several retries were required. If that happens, it probably means that the disk is not in very good shape, and that may get written to the operating system log, but because the operation succeeded, no error will be reported to PostgreSQL, and therefore, if you just look at the PostgreSQL log, you will not know that there is a problem. Finally, administration. I feel a little bit silly having to give this piece of advice to everyone, but experience has proved that it is an absolutely necessary caution. Please do not modify the data files in the PostgreSQL data directory in any way, except by letting Postgres modify them for you. In particular, do not remove files manually from anywhere in the data directory. With the exception of a couple of text configuration files like PostgreSQL.conf and PGHBA.conf, all of the files in the PostgreSQL data directory are intended to be managed entirely by the database system. For example, if you look at the files that are in PGWall, or in older releases PGXlog, the system arranges to automatically remove those files when it believes that they are no longer needed. So sometimes a user goes in and looks at them and says, well, I don't think that file should be needed, and I'm going to remove it. And very often the result of that is the user ends up in a bad situation, because PostgreSQL wants to remove that file just as much as the user wants to remove that file, but PostgreSQL is following an algorithm to determine whether or not that file is needed. And if that file is there, it is probably because PostgreSQL thinks that that file needs to be there, and you can't just remove it. So if you see files accumulating in the data directory that you don't think should be there, you really want to try to work with the database system and figure out why it thinks that those files should not be removed, and convince it that it actually should remove those files. If you just remove them, you're likely to end up in trouble. I've given this talk a couple of times previously, and I got a lot of questions about this particular point. A number of people came up to me after I gave the talk and asked me about ways that they had modified the PostgreSQL data directory, and so I found out even more unsafe things that people are doing. So I wrote a whole blog post based on that conversation, or those conversations, and I put the link here on the slide in case you're interested in reading more about this topic. A closely related point is that you should not run antivirus software on your database server. If you absolutely have to run it, at least exclude the PostgreSQL data directory, but understand also that that may not be good enough, because the antivirus software does not necessarily totally ignore that directory just because you put it in an ignore list someplace. When you really think about it, antivirus software is kind of a surprising thing. Its job is to remove viruses, which means that its job is to modify somebody else's files. And it also quarantines infected files, which basically means removing them. So here you have a piece of software whose whole job is to modify and remove files that belong to other programs. And, PostgreSQL is just not going to cope with that. It expects that it is managing those files and that they're not being randomly modified by other processes. Another thing that you should not do is remove the postmaster.pid file. If you do, you might find that you're then able to get multiple copies of PostgreSQL to run at the same time on your data directory, and if that happens, then you will definitely end up with a corrupted database. And finally, and going back to a couple of the points that were made on earlier slides, a really good idea is to perform plug testing. In many cases, a modern PostgreSQL deployment is going to involve a number of different components, and you can pull the plug on any one of them or any combination of them or all of them at the same time. And, it's good to run some experiments here and see what happens. You want to find out that if you repeatedly remove the power from your database while it's under load, nothing terribly bad seems to happen, and your database doesn't seem to end up getting corrupted. If you just test it while the system is idle, you're probably not going to find out very much. If you test it under load, you have a better chance of discovering some problem that will cause database corruption in your environment, and then maybe you can do something about that before it hits you for real. So let's suppose that we did our best to avoid database corruption, and that we also did our best to detect database corruption, and now we want to know whether we actually got any database corruption. The good news is that in most cases, you're going to see errors in the log if your database is corrupted. That's not necessarily true. There are certainly situations in which you don't get errors, but you still have corruption. But it's very common to have errors in the logs as a result of corruption, and that's often how the problem is detected. Unfortunately, there's a lot of different errors that you could get depending on the exact nature of the problem, but in general, what you want to be looking for is errors that seem to be complaining about things which are internal to the database rather than user-facing things. I'll give a few examples of those kinds of error messages in just a moment. If you don't get errors, you could see other kinds of symptoms that might also indicate corruption, such as crashes or wrong answers or infinite loops. And those problems can be hard to diagnose because it's easy to get confused about whether the thing that you're seeing is just a bug or whether it is actually the result of some kind of database corruption. But if you get an error, it'll probably look something like one of these things. This is just a short list of examples. It's not intended to be comprehensive. We could go on for pages and pages and pages with other messages that are different from the ones that are shown here. But I think this is enough to illustrate the basic theme. You might get an error message like, could not access status of transaction 3881522, or could not read block 123, or failed to re-find parent index key in some index, or cache lookup failed, or found multi-exact 123 from before rel min mxid 456, or could not locate a valid checkpoint record. And the thing to notice about all of these messages is that they seem to be complaining about something which is internal to the system. It's very different than an error message that says something like, well, that table doesn't exist, or you're trying to violate a foreign key constraint. Because if you get an error message that says that a table doesn't exist, the most likely reason why you're getting that error message is because you specified the name of a table that doesn't exist and probably never existed in the system, or a table that someone has dropped. You're not finding the table not because of anything about the database being wrong, but because of something that your application is doing. And similarly for things like unique index violations and foreign key violations. Those are typically just the result of whatever the application behavior is, and they don't indicate any kind of problem with the database itself. But these error messages that I'm showing here are different because these error messages are all talking about internal things, the status of a transaction with a particular number, a block in some file that's managed by the database, some kind of thing that's internal to an index, a cache lookup failure. It doesn't really matter whether you know what these things are specifically or what they refer to. Certainly, if you want to know what one of these things refers to, you can talk with your PostgreSQL support provider if you have one, or make an arrangement with one if you don't have one yet, and they may be able to explain it to you. But even if you don't have access to that information for whatever reason, you can still sort of understand that these don't seem like complaints about things that the user did. These seem like complaints about something that's inside the system, and that's a clue that perhaps you've got a corruption problem. So if you do have a corruption problem, what do you do about it? Well, the thing you should try to avoid doing is you should try to avoid fixing the corrupted database. You should look for some other alternative. For example, if you have a master and a standby, and the master seems okay, but the standby has a problem, don't try to fix the standby and put it back into service. Just rebuild the standby. Get rid of the database cluster that's currently on the standby. Do something about any hardware problems that may exist on that standby, and then reclone from the master and create a new standby. Or, if the problem is only with the master and you have a standby that is unaffected, then maybe you want to fail over to that standby. Or maybe you can restore the master from backup. Another option that's viable for some people is to rebuild the data from some other source. For example, if you're using your PostgreSQL database as a reporting server where you import data from other sources into PostgreSQL and then you use PostgreSQL to run reporting queries, you don't really need to fix your broken database. You can just get rid of it, re-import the data from the original source into a fresh database, again after correcting any hardware issues that may exist, and then you're in good shape. But sometimes none of that is possible. Sometimes you only have one copy of the data and that copy is corrupted. Or sometimes you have multiple copies of the data, but you find out that they're all corrupted in the same way. And so in that case, your only choice is to try to get some data out of the damaged database. I feel the need to insert a disclaimer here. If you decide to try to extract your data from a damaged database, I really encourage you to proceed with great caution. Asking for help is not an admission of weakness. It's just a really good idea when you're dealing with a complicated technical problem. I also want to say that, as with any talk that I give, the advice that I'm about to give you is based on my experiences, and I hope that you may find it helpful, but I'm not promising anything. So if you try the stuff that I'm about to explain, you do that at your own risk, and you may lose your data, you may further corrupt your data, and I don't want to be responsible for that. So just a disclaimer before we go on. So that being said, the basic idea here is that you're going to do two things. First of all, before you do anything else, you're going to take a complete backup of the damaged database cluster. You want to copy every single file from that database cluster to somewhere else, someplace safe, someplace where it's not going to get lost, damaged, or modified in any way. And the reason why that's so important is because your attempts to recover the data may make the situation worse, possibly much worse. And I think as you see some of the things that we're talking about at the next couple of slides, you may understand why that is such a large danger. But there are even more dangers than the ones I'm going to discuss here. It's very, very easy in the process of trying to recover data from a corrupted database to have additional damage occur. And you want to at least be able to get back to the state that you were in when you began trying to recover your damaged database. So make a copy. Now, once you've done that, your goal should be to use pgdump to back up the contents of the database and then restore those database contents into a new database created by a new initdb. Sometimes a person who's in this situation of trying to fix a damaged database will want to just kind of hit the database with a big enough hammer that it starts running again and then put it back into service. And I strongly recommend against that approach, because even if you seem to have fixed the most obvious problem that you have, it's very easy for the same thing that corrupted the database originally to have created latent problems that will not manifest themselves for some period of time, possibly months or even years. So you don't really want to be in a situation where you have a corruption event and then you think you fixed it, and then 6 months later your database goes down because of some latent problem that you didn't realize when you were trying to conduct a repair. So I strongly recommend that if you have a corruption event, you do go through a dump and restore process. But the problem is that's not necessarily super easy to do. And one problem that you might run into is that you have a database that you cannot start. If you can't start the database, then you can't run pgdump. And so then you won't be able to do what I just described. So in that case, you need to get the database to start somehow. And there is a tool called pgresetwall or pgresetxlog that will very often allow a corrupted database to start. It will not fix your database. In fact, your database will probably be more corrupted after you run pgresetxlog than it was before you did that. But it probably will start. This does depend on exactly why it won't start. So just to provide a little bit of clarification, the most common reason why you end up using this tool is because you lost all of your wall files and you don't have any way of recovering them. If there's nothing in pgwall and you try to start the database, it's not going to work. You need to have those wall files. So hopefully you do, but if you don't, pgresetwall will allow the database, again, to start. It will also help you if you've lost PGControl or PGControl has been corrupted and you don't have a way of getting back to a good version of that file. There may be some other circumstances in which this tool is useful as well, but you really don't want to overdo it. This is a big hammer, and again, its only purpose is to try to get the database to start up. It will not fix anything else that's wrong with your database. In some cases, you may have a database that is so badly corrupted that there is no hope of starting it. For example, you might have lost the entire database except for a handful of files. And if that has happened to you, you're never going to be able to start the database pretty much no matter what you do. In that case, you may want to look into an open source tool called PG File Dump. It was originally developed by Tom Lane when he was at Red Hat, and it's still being maintained by other people now. And one of the things that those people did is in newer versions, it can recover data from raw files without needing a running server. So if you have a database that's so badly damaged that you're never going to be able to start it up, then that may be useful to you. Now, if you get the database started, the next problem that you might run into, or one of the next problems you might run into, is that you might not be able to successfully dump the database because pgdump might fail. pgdump has various internal sanity checks built into it, and on a corrupted database, sometimes those sanity checks can fail because the state of the database isn't very sane. And if that happens, then you need to find some way to work around the problem. One really powerful technique is to just drop stuff. If you are having a problem with a temporary table or an unlogged table, or maybe with a stored procedure or something else that doesn't contain critical data that you really need to have, consider just dropping that object. Remember, you made a copy before you started all this, so you can always go back to the state where you had that object and try to do something with that specific thing later. But dropping stuff that's making the dump fail is a very powerful way of getting the dump to succeed, and it very often works. Another thing you can do is reindex an index that can't be dropped. For example, if you have a problem with a system index and the system index has a corruption issue that is causing pgdump to fail, then you might consider reindexing that index. You can't drop the index because it's a system index, but you could reindex it. And there are other situations as well where you can work around problems with index corruption by reindexing. Another thing you can do is, instead of trying to dump the entire database, you can try to dump individual tables or schemas. And sometimes that will succeed where dumping the whole database fails. If a dump of a particular table is failing, then the whole idea of using pgdump is something you're going to have to give up on. But you might be able to extract some data from that table using a select statement. There's a hidden column called CTID that represents the physical position of a tuple within the table, and filtering on that column can be very helpful because you can try to pull out specific tuples by physical location, or you can try to exclude certain tuples that you know are corrupted by physical location, and then just try to get the rest of the data out of the table. One other thing that I can recommend if you are having trouble getting pgdump to work on a database that is running is to use a utility that Enterprise DB publishes called PGCatCheck. This is a little open source tool that we have up on our GitHub, and it's useful for diagnosing catalog corruption because it will run through all of your system catalogs and look for stuff that seems to be messed up, and it will print out a bunch of messages that will tell you about exactly how things do not seem to be correct. I helped design this tool. I helped write this tool. I don't know whether you'll find it useful. I find it quite useful. It tells me what I want to know, but I'm not 100% sure whether it will tell you what you want to know, but I hope it will. I think it's a pretty cool way of finding out exactly what's wrong with your system catalogs, and in particular how widespread the problems are. Like when you start to run pgdump and something fails, you may wonder, do I just have a problem with one of my tables, or do I have like 600 instances of this problem? It could be either one. You may not know. And if you run PGCatCheck, there's a pretty good chance that you'll find out which one it is. And that can help to inform the strategy that you choose to pursue in recovering your data. Now, you may think that if you get the database to start and you manage to run pgdump, then you're out of the woods, because now you've got all of your data in a text file. And so what can possibly go wrong at that point? But it turns out that even once you reach that point, you can still have problems. And the reason for that is because the dump can still contain logical inconsistencies. There can't really be anything physically wrong with the dump because it's just a text file. It can't have bad metadata or whatever the way that the running database system can. But it could have, for example, duplicate rows in duplicate values in what's supposed to be a column with a unique index, or it could have foreign key violations. Of course, unique index violations and foreign key violations shouldn't happen in a database, but in a corrupted database, anything's possible, and so you might have those kinds of problems. And there's no automated solution to those problems. It's just a question of a human being needing to look at it and decide what to do. If you have two records where there should only be one, you could merge them, you could delete one of them, you could renumber one of them, who knows? Somebody who understands what the data is supposed to mean and how it's intended to be used will need to look at the data and make an intelligent decision. But if you get through all of these steps and you get the database started, if it wasn't running already, and you dump out your data and you restore it into a new cluster, then there's a good chance that you will probably have most of your data back and you'll have it in a cluster that is in good shape. And so then as long as you make sure to also investigate why the data corruption happened and fix any underlying problem that led to it, you should be in pretty good shape. All right, thank you very much. Thanks for coming to the talk. I believe we have a short Q&A session after this. So looking forward to any questions, and thanks a lot.
Okay. Welcome, Robert. Thank you very much. It was a very clear talk, and I
Thanks.
Enjoyed it. I think you have already covered all the questions in the chat.
Yes, I think so.
Don't you want to comment on? I also didn't know that we can enable checksums on standby. That's actually seems suspicious.
I actually didn't realize that that was possible either. I'm kind of surprised that full page writes doesn't mess it up, but I guess it doesn't. Because I'm sure Mikhail knows what he's talking about.
I have a question. How often do you actually try to manually recover the corrupted database? I know this is the last option, and usually you want to just take your backup, whatever freshness it is. But how often do you fire up Hex editor and try to?
I actually never go as far as hex editing the database, or almost never. I mean, I might have done it once or twice, but having to use PG reset xlog and then fix whatever makes it not dump and then do a dump and restore. I mean, it's pretty common. Like, it doesn't certainly happen to me every day or to EDB every day, even with the number of customers we have. But I mean, there's definitely at least a case every month or two with some customer. I think there's a lot of ways to mess up your database or to have your database get messed up. And you know, if you have enough customers, then people will do it all the time. So
sure.
I think it's very rarely necessary to go down to the level of trying to recover individual pages, or at least it's been my experience that that's very rarely necessary. But you know, having people who remove their wall files or mess up the backup and restore or have a disk fail or something like that, those things, they don't happen every day, but it's pretty regular.
Okay, thank you. We have a question in the chat. Can dropping corrupted objects be more risky? Is it safe in common case?
Well, the big risk is that you're going to lose the object that you drop. So, you know, hopefully you have a backup of your corrupted cluster, so you're not losing it permanently. But you know, it will be gone, right? If the drop succeeds. I have not personally experienced a case where dropping a corrupted object made things worse for the rest of the database. I guess one exception to that is there is a parameter called 0 damaged pages, which I did not talk about in this talk, and I recommend that you never use it because every time I've tried to use it, I've made things much, much worse very, very quickly without intending to do that. So I don't think that's actually a good solution to any problem. But if you activate that setting, then doing practically anything to the database can cause more of your data to disappear, which is really bad. But apart from that, I don't think it's particularly unsafe to drop objects, except, of course, for the objects that get dropped. It's very unsafe for them.
I wonder, when you have this corruption, do you have a statistics of which size the corruption has? Is it one sector or how it goes?
I don't think it's usually one sector. I don't have statistics. I think it would almost be meaningless to compile statistics because there's so much variation. I definitely have seen examples of customers who have, I think of all the cases that I've tracked down personally, the least corruption I ever saw was somebody who had 2 bytes of corruption in one data page. And as far as I could tell, everything else in the entire database was fine, but somehow the info mask field of one tuple got overwritten with garbage, and the tuple became unreadable as a result of that. So that was the smallest amount of corruption that I've ever seen. And small amounts of corruption are actually pretty common because, if somebody does something like remove all of their wall files, they are often doing that on a database that's not very important. And that's why there wasn't some kind of safeguard in place to make sure they didn't remove all of the wall files. Well, if you run PG reset wall or PG reset xlog on a database that wasn't doing very much, or maybe wasn't doing anything, after losing all the wall files, you're probably not going to have very much corruption. You certainly might have some, but it's probably not going to be all that serious. And if you do a dump and restore afterward, chances are good you're going to get back all of your data without any really big problem. But I have seen cases where databases are extremely severely corrupted, and that usually happens when the thing that is causing the corruption is left unaddressed for a long period of time. So if, for example, you're doing your backup and restore procedure wrong, and you do a lot of backups and restores over and over and over and over again, then the problem just gets worse and worse and worse and worse and worse because you haven't treated it, you haven't corrected it. I've actually seen 2 different examples of customers who did exactly that thing and ended up with really, really severely corrupted databases. I think the same thing could also happen due to a hardware problem where the issue wasn't addressed for a long period of time. Yeah, but I think those cases usually get reported a little bit faster. It's more common, I think, when somebody has a hardware problem or hits a bug. They tend to notice those cases a little bit faster, whereas the cases that are caused by not being careful about administration, it's easier for that to be a problem that kind of goes on because the lack of careful administration can also hinder noticing that you have got the problem once you've had it. But it comes in all varieties. I mean, I've seen ZFS-induced corruption where there was a pattern to the corruption, but it affected basically the entire database or like large chunks of the database. So I've definitely seen severe cases of corruption that were software-induced. But yeah, the really severe cases generally involve doing something bad over and over again rather than just once.
Okay, thanks. By the way, we have a question about ZFS. Can we use full page? Can we turn off full page writes on it?
Nope.
Right.
Next question. You can't turn off full page writes. It doesn't work. You will get corrupted option. And at least in my experience, using ZFS will also give you corruption. So if you have ZFS and full page writes turned off, you have two potential sources of corruption. I don't know. I don't want to be too hard on ZFS. It might be safe in some configurations, but I've seen several customers who had incredibly bad experiences with it that were pretty clearly due to ZFS and not anything else. So I've become very skeptical of it. There may be people for whom it works great, and I just never hear from them because they don't have any problem. But I've heard from some people who did have problems, and they were caused by that, and they were very, very bad problems. So I would not want to put my data in it on the basis of what I've seen. And I definitely would not want to turn off full page writes. Of course, he's now asking why, which is a great question. The big thing is that the buffer pool for Linux, the in-memory buffer pool, uses 4K memory pages, and Postgres uses 8K pages. So even if at the level of your disk, there's no problem with torn writes, you can get half of a page written to disk and not the other half, because as soon as Postgres writes the data out to the operating system, the 8K page that it has internally gets split up into two 4K pages in the operating system buffer pool, and then you can have one of those pages be modified and get written down to disk in the modified version, and the other one doesn't if the system crashes at just the right time. Even if everything down from the buffer pool layer all the way to the disk is atomic in 4 kilobyte or 8 kilobyte or some larger units, which is, I mean, maybe it's the case, but even if all of that's true, you're already dead by the time that Postgres wrote the data to the operating system buffer pool, and so nothing after that actually matters. You can't fix that problem once it's happened.
Okay. You have also mentioned that you have seen a couple of times memory corruption issue. I wonder how it looked like, because recently we had what seems like a memory corruption issue with one customer on a very big machine, and it looks like it is a cache coherence problem.
Oh, interesting.
The corruption size was 46 bytes, and our hypothesis is that it occurred while moving memory page, a cache line between two NUMA nodes. So
that's really interesting. I haven't seen a case like that myself. That's a cool story, though. I'd be interested to hear more about it if you find out more about what happened. The cases where we saw it at EDB were years ago now. There were two cases that I can remember, and they were separated by a number of years, but they're both old. So I don't remember the exact details of what happened. I'm pretty sure that at least one of the cases, the machine got really slow in addition to the data being garbled, and so the speed impact of it was part of the tip-off that eventually enabled tracking the problem down. But unfortunately, my memory of all of this is just not current, because it is pretty uncommon. When something goes bad, it's usually something related to the permanent storage rather than the memory. I just wanted to mention the memory in the talk because it can happen. You would think that if your memory were corrupting data, the whole system would just go down and you would be offline. And I think that's probably often true. But there are some cases where you have marginal corruption in memory, where like you have a small percentage of your physical memory that is lightly corrupting the data, and a small percentage of the bytes on the page gets scrambled every time it passes through there, and that you can actually survive running with for some period of time. I think that kind of problem is very hard to run down. Fortunately, it's also very rare.
Okay. Thank you very much. I think it's our time to
thank you
to finish. I also hope that you will be available in the special chat for additional questions.
Yeah, I'll pop over there next.
Okay. I also remember a couple of years ago, Oleg Bartonov told me that he had invited you to the PGConf conference. It was offline back then, of course, and you said no, no Russia, no way. So I'm especially glad to see you here.
Thanks.
I also remind to our listeners that you can star the talks you like. This is our last talk for today, but tomorrow we have full 3 streams of various talks, and you can right now form your schedule by selecting the talks on the side. And we also have a lightning talks track, so if you have an interesting subject to speak on during 5 minutes, you can submit it and report. Thank you very much, and goodbye. See you tomorrow.